Hey people, and welcome to this video. In this video, we'll be working on the grade 12 preparatory exam for 2022, and this is specifically mathematics paper 1. Remember that the marks allocated is 150, and this exam is for 3 hours. Okay, so the instructions as usual, make sure to round off to 2 decimal places unless stated otherwise, and you have an information sheet at the end of the question paper. Okay, with that being said, let's get into this video. Question 1.1.1, we are told to solve for x in this equation, and this is for 2 marks. Okay, so do you see that we have a value multiplied by another value, and it gives us 0. So the only way this is possible is if the first factor is equal to 0 or the second factor is equal to 0. So we're going to say 2x equals 0 or x squared minus 1 is equal to 0. Here, if we divide both hand sides by 2, x is equal to 0. And here, you see that we can just transpose 1. So x squared is equal to positive 1. And if we square root both hand sides, you need to consider the positive and the negative solution here, because 1 squared gives you 1, but negative 1 squared also gives you 1. So x is equal to negative 1 or positive 1. Okay, so just to show that these are your 3 values, your x values, we can just write it like that. Okay, so that is our answer, 1, 2, 3. Those are our answers, and moving on to the next question. Question 1.1.2, we are given an equation and we're told to solve for x correct to 2 decimal places. So it means that we're going to have irrational solutions. Okay, so what is wrong with this equation and why can we not solve for x right now? That's because we have an x in the denominator. Okay, so in order to fix this, we're going to multiply both hand sides of this equation by x. So we still have the x, minus 6 plus 2 over x is equal to 0, and that also multiplies by x. And now this is going to be x squared, and that's negative 6x plus 2. See how the x and that x will cancel in the denominator, is equal to 0. Okay. We know that we can't factorize because we have to correct 2 decimal places. So we need to use the quadratic formula here. And here's the quadratic formula. And in place of a, b, and c, we'll substitute our values. So remember, this is a quadratic equation in the form of ax squared plus bx plus c is equal to 0. So we can see that the value of a is 1, value of b is negative 6, and c is 2. So let's substitute. So this is x is equal to negative, and we have negative 6 plus minus the square root of negative 6 all squared minus 4 times 1 times 2, and then all over 2a. So 2 multiplied by 1. And let's find our solutions. So I'll go ahead and start with the positive solution first. Okay, and this is our first x value. X is equal to 5 and you see that 5 is going to round the 4 up to 5. So we have 5.65, or we'll just say x is equal to, and we'll change that, plus 2a minus. And that is 0.35, rounded down to 2 decimal places. And that is our answer. Moving on to the next question. Question 1.1.3, we have an inequality, and we need to solve for this inequality. Okay, so straight away notice that one hand side is not equal to 0. So we cannot just work with this quadratic expression. We need to first distribute. So x times x is x squared. And then we'll say plus 4x minus x, which give us a positive 3x. And then negative 1 times 4 is negative 4. And then we can just go ahead and transpose that 6. So it's negative 6. And that is greater than or equal to 0. So they become minus 10. Okay, so open up 2 brackets. Remember, it's still greater than or equal to 0. X times x gives us x squared. And then we need factors of 10 that can give us 3. Okay, remember that 10 is negative here. So you can try factors like 5 and 2, because 5 and 2 can give you 3. And to ensure that the 3 stays positive, but one of these factors should be negative, we can give the positive to the 5 and the negative to the 2. So this is what we have. So our critical values are x equals negative 5 or x is equal to 2. So this is what we have, and let's solve for this inequality by using a graph. So this is a parabola, right? At this point, it's a parabola and we need to find the values of x for which y is greater than or equal to 0. So the graph should be greater than or equal to 0, meaning it should have y values greater than or equal to 0. Okay, if we had a y-axis, the y values greater than 0 are values that lie above the x-axis, okay? And then values less than 0 lie below the x-axis. So that's what we just can think about when we solve for this. So let's put our critical values down. This is negative 5, and this is 2. And we're just telling them the values of x that are greater than or equal to 0, meaning we're looking for parts of the graph that lie above the x-axis. So that's over here, that's above the x-axis. That is also above the x-axis. And if you line this down to the x-axis so that you can understand where exactly these x values are, you can see that these are values that are less than negative 5. Okay, but we're going to have to say less than or equal to negative 5 because we're specifically trying to find the values of x for which this graph has values greater than or equal to 0. If you substitute negative 5 in place of x here, you get a y value of 0, okay? And then likewise here, if we line this down, we can see that these are values that are greater than or equal to 2. So we can simply say that x is less than or equal to negative 5 or x is greater than or equal to 2. And that is our answer. Okay, and moving on to the next question. Question 1.1.4 says we have to solve for x in this equation with surds. Now, do you notice that the surd that they have presented, that they've just been repeated? So you can use the k method substitution here. So you say let k be equal to whatever was repeated. But I'm going to use a different approach here. So let's say we had this, and the only problem here in solving for x is, yes, we have a surd, but we also have that surd in the denominator. So we can get rid of that. And how we can just do this is simply by multiplying both hand sides of the equation by this, or you can also see this as cross multiplying. So we're saying 1 times 10 is equal to 10, and all of this multiply by this. Now this is one term. These are two separate terms, okay? This is one term and this is another term. So this one term will multiply to both terms like this. It's the square root of x minus 2 multiplied by that. But I feel like I'm just wasting time by still writing it in this order since I already said we were cross multiplying. But it's fine. So when cross multiplying, so you can just better see what is going on, these two multiply. Now, you see, if you had, for example, the square root of x multiplied by the square root of x, because they're the exact same thing, they could be represented as the square root of x all squared, okay? Because you just multiply the same thing by itself. And so that radical will break open because of this. And so that's really what happens here, okay? They multiply, they become the square root of x minus 2 all squared, and that breaks open, and it's now x minus 2 that we have there. And then square root of x minus 2 multiplies to 3 and becomes positive 3 root x minus 2 is equal to 10. Okay, now we still have a surd. So we can just ensure that the surd is left on one side and take everything else over to the other side. I like to avoid the x being negative because it's just easier to distribute when it's not negative. So I'll leave it here. We have x minus 2 and let's transpose the 10. So it becomes minus 10. And so that is minus 12 is equal to, and let's take this surd over. So it becomes negative 3 square root x minus 2. Okay, at this point, we can get rid of that surd by squaring both hand sides of this equation. So this is equal to, and we have, let's distribute here. So x all squared is x squared. Negative 12 all squared is positive 144. And then first times second term is negative 12x. And then you multiply that by 2. So this is negative 24x is equal to, and over here, this gets squared and becomes a positive 9. And then this gets squared, and we saw what happens when it gets squared. The root will break open, and now we have multiplied by, it's still multiplying by this number here, x minus 2. Okay, so this is what we have, and we can just distribute that. So this is x squared minus 24x plus 144 is equal to 9x minus 18. And we can transpose everything. X squared minus 24x minus 9x plus 144 plus 18 is equal to 0. So x squared, and then when we subtract negative 24 minus 9 is negative 33x. And then 144 plus 18, that is already a 50, so 162. So positive 162 is equal to 0. Okay, now we need to factorize this. So we have a number like 162. Let's just see what we can get from this. 162. If we say divided by, we need a big number. But you see that the middle is negative. So they must both be negative. So what numbers can you subtract that give you negative 33 but are factors of 162? Let's try 6. So 162 divided by 6 is 27. And so you see x times x gives us x squared. And if you say negative 27 multiplied by negative 6 gives 162, positive 162. And if we subtract them, they do indeed give negative 33. So this is minus 27 and minus 6. And so x is equal to 27 or x is equal to 6. So we have two solutions here, and we need to still make sure that these solutions are actually valid. So you go to your equation, right? The initial equation, and you need to ensure that the left-hand side is equal to the right-hand side. It doesn't even have to be the initial. It just has to be at the point before you squared both hand sides. So even this equation is fine, okay? So let's see what we get. If we substitute in place of x, 27, let's see what we get. So if we have 27 here and 27 here. 27 minus 2, we get 25. Square root of 25 is 5. 5 plus 5 is 8. So let's see if this right-hand side will also be equal to 8. So again, that gives us 5. And 10 divided by 5 is 2. These are not the same numbers. So we can see that x is not equal to 27. Okay, it doesn't work for that. So let's try 6 and see how this works out. So if we substitute 6 here and 6 here, 6 minus 2 is 4. Square root of 4 is 2. 2 plus 3 is 5. We also know that this gives us 2 because it's the same thing as that. That was 6 minus 2, which is 4, okay? And square root of 4 is 2. So 10 divided by 2. So 10 divided by 2 is indeed 5. So you see that 5 is equal to 5. The left-hand side and the right-hand side are equal. Therefore, x is equal to 6, but it's not equal to 27. And that is our answer. Moving on to the next question. Question 1.2, we have a simultaneous equation, and we are told to solve for x and y. Okay, so look for the linear equation or the equation that can be made linear. And I'm saying this because sometimes they will give you an exponential equation. Now, the thing about exponential equations is you can still get a linear equation from it. So something like 2 to the power of x is equal to 4. Don't get afraid if this is one of the equations or another exponential equation or even an equation with log, because it can still be expressed as an exponential, which can be expressed as a linear. See, if you have 2 to the power of x and you make this a base of 2, so 2 squared, you see that x is equal to 2 in this case. So that's why you shouldn't be afraid if they give you an exponential or even an equation with log. Okay, but that's besides the point. We're going to choose the equation that is linear because we can easily make a variable the subject there. So this is our linear, and we'll take this x minus 2y equals 1, and we can make x the subject by transposing negative 2y. So x is equal to positive 2y plus 1, and we can go ahead and call this equation 1. And so this is equation 2, and we can go ahead and substitute equation 1 into equation 2. So wherever you see x, replace it with 2y plus 1. So this is 2, and then there's x. So it's 2y plus 1 all squared minus, and we have xy. Now, it's best to put the y first because you know that in place of x, you need to replace it with this. So minus y, and then 2y plus 1, minus 5y minus 3y squared minus 2 is equal to 0. Let's distribute and solve for y. Okay, so 2 multiplied by, we're going to square the first term. That's 4y squared. Square the last term is positive 1. And then first term times second term is 2y times 2 is positive 4y. Okay, then distribute here. That's negative 2y squared minus y. And here we just have minus 5y minus 3y squared minus 2 is equal to 0. Okay, let's distribute. So this is 8y squared and then positive 8y, positive 2. And do we have any like terms here? Yes, we do. We have negative 2y squared and negative 3y squared. So that is minus 5y squared. And these two also like, so negative 6y and minus 2 is equal to 0. Okay, then these two simplify to 3y squared, and we have 8 minus 6, and that is 2, so positive 2y, and the constant, that's just positive 2 minus 2, which is 0. Okay, so this is what we have, is equal to 0. Okay, so now you see that we have a binomial, and we can just take out a common factor of y. So y comes out as a common factor, and what are we left in the first term? 3y squared divided by y is 3y, and 2y divided by y is positive 2, is equal to 0. And here we have the same case as in question 1, where we have a factor times another factor give you 0. So it means that it's either that this is equal to 0, so y equals 0, or the second factor, 3y plus 2, is equal to 0. So if you transpose the 2 there, we get negative 2. And if you divide both hand sides by 3, y is simply equal to negative 2 over 3. So these are the two y values that we have. And now we have to find the x values. So just look through your equations and look for the equation that has x as a subject. Okay, take that equation. And this is x is equal to 2y plus 1. So we'll say x equals 2y plus 1. And in place of y, we can substitute 0 to find out the x value that goes with this y value. So x is equal to 1, or, and again here we'll substitute this y value. So 2 times negative 2 over 3 plus 1. Okay, let's see. So that is just going to be negative 4 over 3, and the plus 1, we can just make the denominators the same and rewrite it as 3 over 3. So negative 4 plus 3 is negative 1, and so we have negative 1 over 3. So these are our values. When x is equal to 1, y is equal to 0, or x is equal to negative 1 over 3, and y is equal to negative 2 over 3. And that is our answer. Moving on to the next question. Question 1.3 says 2 to the power of x plus 1 plus 2 to the power of x is equal to 3 to the power of y plus 2 minus 3 to the power of y, where x and y are integers. Determine the value of x and y. Okay, they both have repetition. So we have 2 to the power of x here, 2 to the power of x, 3 to the power of y, and 3 to the power of y. So you can separate them first to better understand it. So this is 2 to the power of x. And then how did we get to 2 to the power of x plus 1? We got that because we had two values with the same base. So base of 2, and this had an exponent of 1, and that's how we got that, because if the bases are the same and you are multiplying, you add the exponents. And so we have here plus 2 to the power of x. And so now you see in this part of the equation, you can see what is common between these two terms. Okay, so this is equal to 3 to the power of y multiplied by 3 to the power of 2 minus 3 to the power of y. Okay, let's take out the common factor. So it's 2 to the power of x that is common. And what are we left with? Here, we're left with 2 to the power of 1, which is just 2. And what are we left with here? Remember, it's the same thing as just saying this divided by that. So those would have cancelled. Here, if you divide this by this common factor, you just get positive 1 because they're the same value. Is equal to, and we say 3 to the power of y, open a bracket. What do we have left? 3 to the power of 2. which is 9. And then here we have, if you divide that, we get -1 because we still have a minus there. Okay, so you can see there's a pattern with 2's and 3's that they're clearly using here. So 2 to the power of x multiplied by 3 is equal to 3 to the power of y, and then 9 minus 1 is 8. But 8 can also be written as a base of 2. Okay, so it will follow that. So multiply by 2 to the power of 3. So 2 to the power of 3 is 8. And so now we see, okay, for this equation to be equal, okay, for the left-hand side to be equal to the right-hand side, then x must be equal to 3, while y is equal to this exponent on 3, which is an invisible 1. Okay, so there we go. You can write this as 2 to the power of x should be equal to 2 to the power of 3, and 3 to the power of y should be equal to 3 to the power of 1. Therefore, x is equal to 3 because the bases are the same, so we equate the exponents, and y is equal to 1. And that is our answer. Okay, moving on to the next question. Question 1.4 says, the equations of x squared plus rx plus m is equal to 0. And then we have another equation. Okay, so we have two equations here. And this is the other one. And they have real and equal roots. We need to remember what that means. Real and equal roots. Solve for the values of r and m if r is greater than 0 and m is also greater than 0. Okay, so the main goal, yes, they gave us two equations, but the only thing that we can actually do with these equations is use the fact that they told us that they have real and equal roots. So looking at this, if an equation has real and equal roots, what does this mean? Well, it means that the discriminant, right? It's quadratic, first of all. They're quadratic equations. So the discriminant is equal to 0. And we know that the discriminant is that part b squared minus 4ac from the quadratic equation. Okay, the part that goes square root b squared minus 4ac. That will tell you the nature of the kind of roots that you have. So this has real and equal roots. So that's the b squared minus 4ac. So in both equations, we're going to ensure that the discriminant is equal to 0. So in our equations, you can see that in this one, it's in the form of ax squared plus bx plus c is equal to 0. So the value of a is 1, the value of b is r, and the value of c is m. So let's find this. So we're saying b squared, which is r squared minus 4 times 1 times c, which is m, is equal to 0. And of course, if you simplify this, it's just r squared minus 4m is equal to 0. I'll hold on to this equation just to see what this one looks like. So here, the discriminant will be found by saying b squared minus 4ac, which is m squared minus 4 times 1, again, times r as c is equal to 0. So this simplifies to m squared minus 4r equals 0. So these are the two equations that we have. And now with these equations, we have to solve for r and m simultaneously. Okay, they've been using a lot of simultaneous equations in this question 1 specifically. Okay, so we have this, and you just have to make one thing the subject. So let's focus on making n the subject. It really doesn't matter because you see that they take the same form, really. So I'm going to transpose that, and we have r squared is equal to 4m, and then divide both hand sides of the equation by 4. Therefore, m is equal to r squared over 4. And I'll go ahead and say this is equation 1. Okay, m is equal to this value, and I'll call this equation number 2. And so we can simply substitute equation 1 into equation 2. So wherever you see m, replace it with r squared over 4. So this is r squared over 4 all squared minus 4r is equal to 0. Okay, so this is r to the power of 4 over, and that becomes 16, okay, when it's squared, and minus 4r equals 0. Okay, so to solve for r, we can take out r as a common factor immediately at this point. You can choose to also multiply both hand sides of the equation by 16 to get rid of that on the denominator. So times 16 and multiply by 16. And so this is r to the power of 4, and then that becomes 16 times 4 is 64. So this is negative 64r is equal to 0. And we can take r out as a common factor. R to the power of 3 will be left in the first term. And in the second term, negative 64 is equal to 0. Okay, same idea they're using. Factor times a factor equals 0. Therefore, r is equal to 0, or r cubed is equal to 64 when you transpose, of course. Okay, so here we can just cube root both hand sides of this equation. Therefore, r is equal to 4. Okay, so here's the thing. R is equal to 4, but they said r is greater than 0. Okay, so we know we can't accept this one. We can just tell them, but we know that r is greater than 0. So this therefore means that r is equal to 4 only. Okay, so if this is the value of r, we can now find m. We can just use this equation. M equals r squared over 4. So this means that we'll just say m is equal to 4 squared over 4. And so you see how that's just going to be equal to 4. So that's our answer. R is equal to 4 and m is equal to 4. And those are our answers. And that is it for question 1. Question 2 says, 2.1, given the quadratic sequence and we have 20, 12, 10, and 14. Okay, we need to determine an expression for the n term of the pattern in the form of Tn equals an squared plus bn plus c. So the first step is we need to find the first differences. So we'll say 12 minus 20, and that is negative 8. And then 10 minus 12 is negative 2. And 14 minus 10 is positive 4. Okay, and then we need to find the second constant difference. So with the second constant difference, you can simply just say, how did you get from negative 8 to negative 2? So you could have said negative 2 minus negative 8, okay, and then add them. But we can also just say we added by 6 to get from negative 8 to negative 2. And then from negative 2 to 4, if this is the second constant difference, it stays consistent. So that's also going to be 6. Okay, we can see that 6 minus 2 is 4. Okay, so this is what we have. And now we equate it to the following. So it means that 2a is equal to 6. And then we say 3a plus b is equal to the first term in the first differences. And then a plus b plus c is equal to the first term in the quadratic. Okay, let's find the value of a first. If 2a is equal to 6, then a is equal to 3. Okay, so a is equal to 3. And then let's find b. So we'll say 3 times 3 plus b is equal to negative 8. And then b is equal to negative 8, and this becomes 9. So if you transpose 9, becomes minus 9. So that is negative 17. And then c, we'll find c by saying a plus b plus c equals 20. But we already know what a is. A is 3, and then b is negative 17, and then plus c equals 20. So 3 minus 17 is negative 14. So we're saying positive c is equal to 20, and we can transpose that negative 14. So it becomes positive 14, and we have positive 34. So this means in the form of an squared plus bn plus c that tn is equal to 3n squared minus 17n plus 34. And that is our answer. Moving on to the next question. Question 2.1.2 says, the first differences form an arithmetic sequence as usual. Okay, this is an arithmetic sequence that we'll have there. And they want us to determine between which successive terms in the quadratic sequence the first difference will be 148. Okay, so looking at these, right, we're saying between which two terms in this quadratic pattern will we have a first difference of 147. Okay, so these continue. Look at the first differences. They want to find out between which two terms in the quadratic will there be a first difference of 148. 148, not 147. Well, we can easily find this because this is a pattern with more than one term that we have, okay? So we can find its formula, and then we can find out which term number belongs to 148 in this first difference. So, for example, this is term 1, term 2, term 3. So let's just find out which term number that would be. It's an arithmetic pattern, okay? That's an arithmetic pattern, the first differences. So it's going to be in the form of a plus, and the value of a here, the first term, is -8. So it's -8 plus n minus 1 multiplied by the difference, which we can see is 6. So we're just trying to find out which term exactly is 148. 148 is equal to, so in place of tn, that's what we put, and we're trying to find the term number. Okay, so -8 plus n minus 1 times 6. If we transpose that, it becomes positive. So that's 140 plus 16, which is 156, is equal to, and we have 6 times n minus 1. And then we can just divide both hand sides by 6. And 156 divided by 6 is 26. So we'll say that if you divide both hand sides by 6, we get 26 is equal to n minus 1. And transpose the 1, it's now plus 1. So n is equal to 27. So in the first differences, term 27 has a value of 148. So we found out what term number this is. If this is term 27, between which two terms would this lie? Okay, it will lie between term 27 and term 28. Because do you see that your quadratic pattern will always have one term more than the arithmetic pattern, the first differences. Okay, just like here we have term 1 between term 1 and term 2 in the quadratic pattern. Term 2 is between term 2 and term 3 in the quadratic pattern. So term 27 would be between term 27 and term 28. So we need to just conclude that and tell them it's going to be between term 27 and 28. Okay, and that is our answer. Moving on to the next question. Question 2.1.3 says, determine the smallest value of n for which Sn, the sum of n terms, okay, is greater than 10,140. Okay, so the sum of n terms. It's just an inequality in this case. So let's find out what the sum of n terms would be. Okay, that formula. So we're working with an arithmetic pattern. We don't know what the last term is, of course, because we don't know how many terms there are. But what we can just use is this formula. So Sn equals n over 2 and then multiply by 2a plus n minus 1 times d. And we have the value of d, we have the value of a. So we can say Sn is equal to n over 2 multiplied by, and this is 2 multiplied by the a value, the first term in the arithmetic pattern is -8, and then plus n minus 1 multiplied by the constant difference, which was +6. Okay, so what we're just trying to find out is for which values of n, what is the smallest value of n for which Sn is greater than 10,140. So we'll just substitute this here and then solve for this inequality. Okay, let's start simplifying. So this is n over 2, and then these multiply to give us -16. And if we distribute the 6 there, that is minus, let's just start with the negative. -6 and then +6n is greater than 10,140. Okay, and we can simplify what is inside first. N over 2, and then we have 6n, and those give us -22. Okay, which is greater than 10,140. And you see that we're going to have to distribute. This is a quadratic equation that we'll have. So let's just transpose this since this side is already not equal to 0. So we have, distribute this here. If you say n over 2 times 6n, then because we have 2 in common, we have 3n squared. So 3n squared, and then that multiplies and becomes negative. You see the 2 is going to cancel. 22 divided by 2 is 11. So this is -11n. And then transpose this. This is -10,140. And this is greater than 0. And we need to factorize this. Okay, so to quickly factorize this, I will still factorize, but I'm actually just going to do this in a quick method. So it's not really factorizing, it's using the quadratic formula, but I'm just going to use the factors that we get from it. So if we put in the quadratic formula, x equals negative b. So negative b, and b is negative 11. So it's minus 11 plus minus, I'll start with the plus, b squared minus 4ac. So that's negative 11 squared. We could have just said 11 squared. Minus 4 times a, which is 3. And then c, which is negative 10,140. And this goes all over 2a, which is 3. Okay, so do you see that one of the factors, one of the solutions is 60? So n is equal to 60. And so what it means about the factor, let's just put that one here. What it means about the factor is that the factor was n minus 60 if you transpose the 60. Okay, so that's how we got n is equal to 60. And then let's find the other factor. So just change that to a minus, and it's a fraction, but you can just put it back as a fraction. So if this answer is n equals negative 169 over 3, then it means that your factor was simply transpose that. That will be n plus 169 over 3. And then it means that this 3 was in front of the n. So it was 3n plus 169. And that's how you said is equal to 0. You transposed it and divided both hand sides by 3 to get back to that. So it's 3n plus 169. So these are our factors, and we already have our solutions now, and we can answer. Okay, so these are not necessarily solutions. I call them solutions. They're critical values because this is an inequality. Okay, so since these are critical values, but you see that this is a negative and it's a fractional number, so we can't take this because these are patterns. You can't have term negative 2, okay, or term negative a half, or term 3 over 2. There's no such thing. Terms represent positions. So the one we'll go with is where n is equal to 60. So let's just see. We still need to solve for the inequality. So it was a quadratic equation, right, expression that we had there. But do you see that this is a parabola? And it's specifically a concave up parabola. Okay, if it's a concave up parabola and the critical values were negative 169 over 3, we won't really consider that one. And the 60, this was just asking us to solve for n where the function is greater than 0. Now remember from the first questions that if the function is greater than 0, we're just referring to the y values of this graph. The y values are greater than 0 where the graph is above the x-axis, and it's less than 0 where it's below. So we're only going to look at parts of the graph that lie above the x-axis. So that's over here, and that's over here. You don't have to really consider this one so much because we're not even going to work with that critical value. So do you see that if you line this part down to the x-axis, you see that these are values that are greater than 60. So we can simply say n is greater than 60. This would be the answer to our inequality. Now let's go back to what the question is specifically asking for. They said determine the smallest value of n for which Sn is greater than, okay, 10,140. We found out that the values of n for which this works is where n is greater than 60. Think about the numbers that this refers to. Values greater than 60 are numbers like 61, 62, 63, and all values greater than 60. They want the smallest value of n. Remember that n refers to term values. They can't be fractions, okay? So it means that our answer for n will have to take the smallest value within this range. Okay, it's not 60 because n is greater than 60, not equal to 60. Therefore, n is equal to 61. That would be the smallest value in this range, in these answers, values greater than 60. Okay, and that is our answer. Moving on to the next question. Question 2.2 says, if we have the sum of a series r plus b, right, starting at r equals 1 and ending at r equals 5, and the sum of that series is equal to 10a, we need to determine b in terms of a. Okay, so let's expand. Now, honestly, with expanding, I just need two things from this. This is an arithmetic pattern, okay, because you're just saying r plus b. Say when r is equal to 1, that's 1 plus b. When r is equal to 2, that's 2 plus b. So it's arithmetic. We just keep adding by 1. Okay, so we add 1 to the previous term. So to find the sum of this series, because it's arithmetic, I'll just use this formula, n over 2, okay, times a plus l. And so from this, you see that all we need is the value of n. How many terms are there? We need the value of a, and we need the value of l. So I'm just going to focus on finding those. Okay, so the value of n is, we'll just say n is equal to, and this is the number of terms. To find out how many terms there are here, you're starting at r equals 1 and ending at 5. So it means there are a total of 5 terms. You can also just say 5 minus 1 plus 1, which is 5. Okay, so 5 terms we have. And what is a? A is the first term. So it's a result of substituting this value, okay, that we start at. So that is r plus b, which is 1 plus b. I'll just call it b plus 1. Okay. And then the last term, it ends at r equals 5. So substitute 5 in place of r. And so L is equal to, that's 5 plus b. And then we can just say b plus 5. So there we go. These are all we need. And we can find, this is all we need. So we'll say S of 5 terms, sum of 5 terms is equal to 5 over 2 multiplied by b plus 1 plus b plus 5. And we know what the sum of these 5 terms give us. They give us 10a. So 10a is equal to, and just simplify. So this is now 2b, and that's plus 6. Okay, I just want to simplify this in the, in a way that I don't have to complicate things. So let's get rid of this 5 over 2. And we can do that by multiplying both hand sides by 2 over 5. So times 2 over 5. It's the same thing as dividing both hand sides by 5 over 2. So this now becomes, you see that 10a is in the numerator. So 10 and 5 have 5 in common. So divided by 5 is 2. So that's 2 times 2a, which is 4a, is equal to, and this cancels, and we have 2b plus 6. Okay, this is our equation. And we simply have to determine b in terms of a. So solve for b and it will be in terms of a. So you can transpose 6. So we have 4a minus 6 is equal to 2b. And divide both hand sides of this equation by 2. Therefore, b is equal to 4a divided by 2 is 2a. And negative 6 divided by 2 is negative 3. And there we go. This is b in terms of a. And that is our answer. And that is it for question 2. Question 3 says, given the following geometric sequence, and we can see it's in terms of x, calculate the sum to infinity. So with the sum to infinity, remember that our formula is the sum to infinity is equal to a over 1 minus r. So we just need the value of a and r. So a is the first term in our geometric series, which is 24 over x. And r is, so we'll find r by saying term 2 divided by term 1 or term 3 divided by term 2, which honestly looks easier in this case. So I'll just say term 3, which is 6x divided by term 2. And so this simplifies to 1 over 2x, or we could just call this x over 2. Okay, the 6 cancels in the numerator and the denominator. So this is what we have, and we're just saying the sum to infinity is equal to a is 24 over x divided by 1 minus x over 2. Okay, so with the 1, you can rewrite 1 as 2 over 2. So this is equal to 24 over x divided by, and that is now 2 over 2 minus x over 2. So the denominators stay the same, they are 2, but then this is now 2 minus x in the numerator, 2 minus x. And because we are dividing, we can simply just tip and times. So we leave the first fraction the same. And so when dividing, we tip, meaning switch the numerator and denominator, and then change this division to a multiplication. So tip and times. So this is equal to, and I don't really see common factors. Okay, so I'm just going to say 24 times 2 is 48 over an x multiplied by 2 minus x. So the x is going to multiply to the 2, given a 2x, and to the negative x, given negative x squared. And that is the sum to infinity. It's also in terms of x. So that is our answer. Moving on to the next question. Question 3.2 says, write down the values of x for which the sequence converges. So the sequence will converge. If it's a converging series or sequence, it will converge when r is greater than -1 but less than 1. Okay, so we just need to find r. We already have r. It's x over 2. So in place of r, just substitute x over 2 is greater than -1 but less than 1. Now we're trying to just solve for x. Find the values of x, okay, for which the series converges. So just multiply through by +2 to get rid of this 2 in the denominator. So it's really just two inequalities, but they've been written together because, you see, we're saying value is greater than -1 but less than 1. So because they were within the same interval, they were written together. So it's still two inequalities. It's still where r is greater than -1 or r is less than 1, but it has been put together. So this is what we have, and we're just solving for x. So therefore, x is greater than, that becomes -2, but less than 2. The signs do not change because we did not multiply or divide by a negative value, and that is our answer. Moving on to the next question. Question 3.3 says, for which values of x will the series increase? Okay, let's take a look at our series and just see what it's doing. So we have 24 over x, 12, 6x, that's 3x squared plus, and then we just keep going. So we need to find out the values of x which it will increase. What controls these terms, like the next term that we keep getting, right? Every consecutive term, what controls that? It would be the ratio, the common ratio. That's what controls what the next term is going to be. It determines that. So if we have to multiply by a value that causes the next term to become less than the previous term, then it starts to decrease. So we see that we can actually control this using the ratio. Because you can look at it for a while and try to control it from here. It may just be because you're going to start thinking, what can I make x so that it starts increasing? Okay, I see that with this, right, we have something like 6x and then 3x squared. You see how I'm just focusing on the coefficient, right? 6 is a number greater than 3. So we can see that, okay, depending on whatever x is, it will probably be generally decreasing. But I don't want to now look at it from there because it's going to be really complicated. Let's just focus on the thing that determines each consecutive term, which is the ratio. The common ratio, r, is x over 2. And now we can actually look at what that is doing to each term. X over 2. So what should x be so that these terms start to increase? Well, this is a whole thing about numbers and really fractions and how fractions work. This is x over 2. You see, with these numbers, if you multiply, let's start like even at 12, okay? If you multiply this by a number that is, let's say, a fraction, a proper fraction, which is a fraction where the numerator is less than the denominator. So let's take a number less than 2, okay? So that would be 1. For example, 1 over 2. And you keep multiplying the previous term by a half to get the next term. Look at what's going to happen. You start at 12, then you have 6 times a half, then you have 3 times a half, then you have 3 over 2. What are the terms doing? They are decreasing, and we don't want that. We want it to increase. So that's what I mean by it depends on the kind of number you multiply, okay, to that previous term. So if you multiply it by a proper fraction where the numerator is less than the denominator, that's where it's going to start decreasing. So we want it to increase. So we need to ensure that we multiply it by an improper fraction. And in this case, this r can only be improper if x is a value greater than that denominator of 2. So if it's numbers like 3 over 2, can't really be 2 over 2. 2 over 2 is 1. And if you just keep multiplying by 1, it's not going to go anywhere. It's just going to stay exactly the same. But if you multiply by a number like 3 over 2, or even 2, which is 4 over 2, then they will start increasing. See, 12 multiplied by 4 over 2, which is 2, is 24. And then the next term, times 2, is 48. And you keep moving up. Okay, so that is how we would control it. We can focus on r, since r is what you multiply to the previous term to get the next term. If we ensure that that value of x, okay, is a value greater than 2, so it becomes an improper fraction, and so it's going to make your terms increase. Okay, so that is our answer. I was looking at r equals x over 2 and determining that if we want this to increase, r simply needs to be a value greater than 2. And that is our answer. Okay, so this method is more like analyzing the way the expression is going to behave, okay, based on what r is. So it's more of an algebraic breakdown of it. Okay, so this is our answer. Moving on to the next question. Okay, and now they say if x is equal to 4, see, that's a value greater than 2, determine the sum of the sequence to 15 terms. Okay, so we just know x is equal to 4. Let's take the sum. We need the sum, but we only have the sum to infinity. So we just need the value of a and r. So a is 24 over x. R is x over 2. Okay, let's determine what r is so we know which formula to use, since this is a geometric sequence. So we have 4 over 2, which is equal to 2. Okay, so r is 2 now. And because r is 2, this is a value that is greater than 1. So let's use this formula. Sn is equal to a multiplied by r raised to the power of n minus 1 all over r minus 1. Okay, this is where r is greater than 1. That's the formula I'm using. So the sum of how many terms do we have? 15 terms. So sum of 15 terms is equal to a, should have found the value of a already. This is 24 over 4, which is equal to 6. Okay, so 6 multiplied by r, which is 2, raised to the power of 15 minus 1 over 2 minus 1. So let's just substitute and find the value. And we finally get the sum of 15 terms is 196,602. And that is our answer. Okay, so that is it for question 3. Question 4 says, the graphs of f of x, okay, which we can see is a parabola in turning point form with a little twist. You see how they added x plus p? Okay, but you know that the standard form actually looks like this. It's a times x minus p all squared plus q. So you notice with these types of equations, okay, the equations of certain graphs with that x minus p, they will usually tamper with that just to ensure that you know what the standard form looks like, okay? And then g of x is a hyperbola, and they did the same thing over there, okay? It's usually in the form of y equals a over x minus p plus q. So let's just keep that in mind. And then they tell us that these are drawn in the sketch below and have the following properties. So a is 5 over 2 and 0. We can see it's a point on the graph of f. It's an x-intercept. And we also told that p is the turning point of f, and it lies on the vertical asymptote of g. Great. So we now know that vertical asymptote, and we know the x value of p. And then we are told that the vertical asymptote passes through 1 and 0, as we can see. The horizontal asymptote passes through 0 and 2, as we can also see that. And the graph passes through the origin. Okay, so the graph of g. So g has a point 0 and 0. And the first question is 4.1. Show that the equation of g can be written as this. Well, we were already told the equation of these asymptotes. We were told the x and y values they pass. So this passes through x is equal to 1. This passes through y is equal to 2. So we know that p is equal to 2 and q is equal to 2. So let's put that down. We know that this should be y equals a over x minus p, but we can see that p is 1, so minus 1, plus q, and that is 2. And so all we need to do is substitute 1 point in place of x and y. If those are filled in, we can solve for a. So do we have a point on this graph? Yes, we have the origin, and it's perfect to substitute the origin in this case because it will actually work. So 0 and 0 as x and y, meaning 0 is equal to, and we're looking for a, so a over 0 minus 1 and then plus 2. And now we can just solve for a. So this is 0 minus 1 is negative 1. A divided by negative 1 is negative a. So that is negative a. When you transpose it, it becomes positive. So positive a is equal to positive 2. And there we go. So we found this, meaning y is indeed equal to 2 over x minus 1 plus 2. Moving on to the next question. Question 4.2 says, calculate the coordinates of P. So full coordinates of P. P is that turning point of the parabola. So if we know that it's a turning point, then they've already given us the equation of the parabola in turning point form. So we can actually use this. So we'll take this, and this point that we have, right, that's going to be in place of P and Q. But remember the story with the P. Okay, so just keep that in mind. And with where P is, it is on this vertical line passing 1 on the x-axis, meaning its x value is 1. Okay, so we know the x value. We just don't know the y value. Now, this actually is not going to be a problem because we will have something substituted in place of that x value of the turning point, and then this is missing. So to find Q, you would just need 1 point on this graph. Okay, if you substitute a value in place of x and y, you have an equation solving for Q. And we can actually do that with this point A. We have a point on this graph, 5 over 2 and 0. So let's go ahead and take our equation. It is this, f of x equals, see, the A value there in front of this x plus p is actually 1. So let's take it as it is. So remember how in the standard form, this is your P, right? The x value of the turning point. And so it should have been A times x minus 1 all squared plus Q. So you just need to ensure that it still reflects that over here. So it's still going to be minus 1 because the value of P is actually negative 1. Okay, so let's just keep it like that. And now we just need to find Q, and we'll use the point A to do this. So this is 5 over 2 and 0. And so in place of y, we say 0 is equal to, and x is 5 over 2 minus 1 all squared plus Q. Okay, this will solve for Q. So 5 over 2 minus 1, that is 5 over 2 minus 2 over 2, which is 3 over 2. And 3 over 2 squared is 9 over 4. So you can transpose that, and now it's negative 9 over 4, and that is Q. So now we know the value of Q, and so therefore P, right, because we know that Q is the y value of the turning points. That's what P and Q are. So P, x value, Q is the y value. So that means that Q is that negative 9 over 4. So there we go. Those are the coordinates of P. That's 1 and negative 9 over 4. So we can say P is therefore 1 and negative 9 over 4. And that is our answer. Moving on to the next question. Question 4.3 says, write down the equation of the vertical asymptote of P if P of x is equal to g of x minus 1. Okay, the vertical asymptote. So the equation of g. What was the vertical asymptote before? It was x is equal to 1. This is the vertical asymptote of our hyperbola. So if it was x is equal to 1, what happened here? You see, when it has to do with translations applied to the equation, you're going to have to translate it first in words. So x minus 1, what does that do to this asymptote? What does that do to this? Well, you're subtracting a 1 from the x. When you add or subtract from the x, this is a left or right movement. If it's plus, it's moving to the left. If it is a minus, it is moving to the right. So we have to translate that and say this is actually a shift 1 unit to the right. And think about what happens. If you have this vertical asymptote at x is equal to 1 and it shifts 1 unit to the right, where will it end up at? So it goes from 1 and it will move 1 unit to the right and it will be at 2. Okay, and that is our answer. So it's not x is equal to 1, it's x is equal to 2. Okay, so with these ones, you always have to just first think about what that translation will look like. That's p of x. Okay, so x is equal to 2 is our answer. Moving on to the next question. The next question, 4.4, says, determine the equation of the axis of symmetry of G, our hyperbola, in the form of y equals mx plus c if m is less than 0, meaning if the gradient is negative. Okay, so you just have to remember what your axis of symmetry equations look like. Okay, so our hyperbola look like that, and it has two axes of symmetry. It has an axis of symmetry with a positive gradient, and it has an axis of symmetry with a negative gradient. It's very easy to remember it if you remember the standard form of the hyperbola. The hyperbola standard form is y equals a over x minus p plus q. You see that minus p plus q part? That's all you have to remember. The equation of the axis of symmetry with a positive gradient is y is equal to literally x minus p plus q. And that's why I said if you remember this, you remember all of that. But they specifically want the one with a negative gradient. So that one works like this. Again, you only have to remember this. You simply put a minus in front of the x minus p. So it's y is equal to negative and then x minus p and then plus q. And so if you simplify this, this is simply y equals negative x plus p plus q. And so that's what it looks like. And if you have the value of p and the value of q, you can substitute it and that will be your equation. So our equation is y is equal to negative x, and let's look at our p and q value. So on the graph, right, what is the p value? So that is that vertical asymptote's value. That is 1. And on the graph, the q value is 2. So y is equal to negative x plus 1 plus 2. And so therefore, y is simply equal to negative x plus 3. And this is our answer. Okay, moving on to the next question. Question 4.5 says, write down the equation of k if k is a reflection of g about the x-axis. Remember that g is our hyperbola. And let's just rewrite the equation here. So g of x is equal to, the a value was 2 over, and that was x plus, we know that, q was 1. So x minus 1 plus 2. Okay, so this is what we had. And they want us to tell them, what would the equation of k be if this was reflected about the x-axis? Okay, let's talk about the reflection about the x-axis. If you have a point anywhere, okay, let's just have a point over there. And let's call this point 2 and 1. Reflect this point about the x-axis. If you do that, this is your x-axis. It means that this point is going to appear here. Now, it's going to be away from this point at the same distance, okay, from the x-axis as it originally was. So this was how many units away? It was 1 unit away because this is the y value, it's 1. Meaning from this point to this point, it was exactly 1 unit. So this will do the same thing. From the x-axis to this point, it's exactly 1 unit down, meaning its y value is now negative 1. But you see that the x value, these are still vertically in line. The x value stays exactly the same. So now we know that a reflection about the x-axis causes the y values to change. Specifically, the y values just change by getting multiplied by negative 1. So this is the graph of g. We know that k of x will be found by making the y values of g negative. Now you see how g of x stands for y. Y is equal to 2 over this, right? So we're going to say it's now going to be negative g of x because we're making all the y values of g negative. And you just have to apply this into this equation. So k of x is simply equal to 2 over x minus 1 plus 2, but you're going to put a negative in front of it because this represents g of x. And once you distribute, k of x is simply equal to, this multiplies in, give it to the numerator. So it's negative 2 over x minus 1 and then minus 2. And that is our equation. Okay, moving on to the next question. Question 4.6 says, for which values of x will f prime of x multiplied by g of x be greater than 0? So they are referring to the y values of this graph. F prime of x, remember that the graph of f is a parabola. So to find out where f prime of x multiplied by g of x give us a value greater than 0, we're just saying where will the y values of this one multiplied by that give us a positive number. Okay, so let's look at the possibilities. If the values of f prime of x are positive and the values of g are positive as well, then they would multiply and give us a positive number. Also, if the y values of f prime of x are negative and the y values of g of x are negative, then they will also give us a value greater than 0. Okay, positive times positive is positive and negative times negative is also positive. So let's look at this. We need to see what g prime of x looks like. Now, this is actually very simple to roughly sketch down because we already have this point, the turning point. You see, when you derive a parabola, it's going to give you a straight line, okay? Because if you have to the power of x, like x squared, if you derive this, it becomes 2x. This is a straight line. So when we derive this, it gives us a straight line. But remember, this is a concave up parabola. So if it was positive something x squared, it's still going to stay positive. So we will have a straight line that is an increasing function, something like that. But there's one specific point that would be important, okay, just because we are looking at positives and negatives. And that point is the x-intercept of this derivative of f. And that will happen here. So look at this. You see at the turning point, right? That x value of the turning point will be the exact same x value as the x-intercept of the derivative of this graph. So this over here is f prime. And now we know where it intersects the x-axis, just over there. Okay, so let's look for the values of x for which f prime is positive and g is positive as well. Okay, so let me just highlight that graph of g, okay, so that we can just focus on it. So this is what we're looking at, these two graphs. Now, do you see that because we are referring to positive and negative values, just notice this about graphs. If the y values of a graph are positive, it just means that it lies above the x-axis. Okay, do you see that all these points on each graph, they all have positive y values. And if it is negative, it has negative y values, it's going to lie below the x-axis. So what we're simply looking for is for the places where both f prime and g are above the x-axis or where they are both below the x-axis. So do you see where they are both above the x-axis? Yes, that's over here. Okay. Now we just need to pinpoint exactly where that starts. So if you looked across and just try to see where does that start, you will see that with the graph of f prime, it hits 0, okay, a y value of 0 here, and then it starts becoming positive. Now, with this graph, okay, do you see that it doesn't have a corresponding y value for this x value? It doesn't even have this x value, really. So, immediately after this is where they both have positive y values, okay? They are both positive all through here. So, if you line this down to the x-axis, do you see that these are values that are greater than 1? Okay, so we'll keep that in mind. This is where x is greater than 1. This works out where x is greater than 1. Okay, do you see anywhere else where both graphs lie above the x-axis? No. So now we have to consider where they lie below the x-axis. So where are they both below the x-axis? Over here. Okay, and where does that start? That starts off if we just keep moving like this. Do you see that the graph of f, right, goes below the x-axis, and for this same x value, not really exactly at this x value, but values just before it, do you see that the graph of g is also below the x-axis? So it starts before 1, But then once you keep moving to this side, you see that the graph of G hits the x-axis, so its y value is 0 there, and then it goes above. So now it's above, we can't take that. So we can only take within this region over here. So we highlight those parts of the graph. It's simply just from here to there, and of course that. Okay, so you can't take this part, okay? Because yes, of course, G, we can see it's below the x-axis, but unfortunately, for those same x values, the graph of G is above the x-axis. It has positive y values. Okay, so these are values that are, it's at the origin and then less than 1. So greater than 0, but less than 1. It can't be equal to 0 because they didn't ask for values that are, greater or equal to 0, just greater than 0. So in this case, this is where x is going from 0 to 1, values greater than 0, but less than 1. And these will be our two answers, okay? So we can just tell them that. So therefore, x is greater than 0, but less than 1, or x is greater than 1, and that is our answer. Okay, moving on to the next question. Question 4.7 says, for which values of k will the equation g of x is equal to x plus k have two real roots of opposite signs? Okay, now when I started hearing two real roots, I was already thinking the discriminant, but here's the thing. You see, the minute they start saying things like of opposite signs, you can't control that with the discriminant. The discriminant can only control roots like this. It can ensure that the roots are equal, okay? Meaning it's one root that you have, something like x minus 1 times x minus 1 is equal to 0. The discriminant can also ensure that you have unequal roots, unequal, not specifically of opposite sides, just unequal, meaning you have something like, for example, x plus 2 and x minus 1, okay, is equal to 0. But you could also have something like x plus 2 and x plus 3 is equal to 0. You see how these are of the same sign? Now, because of this, we can't actually control the roots to the point of even manipulating their signs using the discriminant. But you can do that on the graph. So we need to break this down and think about what this means. They're specifically saying g of x is equal to x plus k. G of x is a graph we already know. They're equating it to x plus k. X, okay, if you say y is equal to x, this is a straight line. So they're equating it to this line, y equals x plus k, and it needs to have two real roots of opposite signs. Okay, let's just quickly understand what it means by roots, okay? Okay, because it's a hyperbola with a straight line, okay? A hyperbola and a straight line intersect because this is x plus k, that's the x plus k, and it's being equated to the g of x graph, okay? So what happens is you have, just a rough sketch quickly, you have your graph of g of x, right? And the way it looks like that. And when we're referring to the roots, we're just referring to the x values at which these two graphs intersect. So this is a root over here. This is another root. You see, those x values of their point of intersections, those are what they are referring to as roots. Okay, now let's quickly talk about why they're called roots. Okay, so if you had to take a hyperbola, right, like the one that we have, so this graph g of x, 2 over x minus 1 plus 2, and you equate it to the equation of a straight line, even if it's just y equals x, right? When you solve for x here, you're going to get those x values of the point of intersection of your hyperbola and the straight line. Okay, this will become quadratic. Like you could just take that over, it's minus 2. Then the minute you start cross multiplying, you see how you get x minus 1 times x minus 2 is equal to 2. This is going to be a quadratic equation. So that's what it solves for. And that's why we refer to these x values as roots. Okay, for this one, to explain this, I'm going to need those graphs. I'm going to actually just draw it down because here it may be a bit limiting. Well, it does look good already here, but I just don't want that distraction of the graph of f. So let's take this as it is, and then let's look at those graphs. Okay, so this is what we have. This is the graph of g, And I'm going to sketch down this graph y equals x plus k, okay, that they equated g to. So I think one of the best ways to draw it right now would be at the origin, like it passing the origin. It's just that line y equals x. So we're just going to manipulate it and see how many roots or points of intersections, those x values, okay, that it has with this hyperbola. So this is y equals x plus k, and let's manipulate it. If we had to take this graph and we need to ensure that it's always going to have two real roots of opposite signs. Okay, of course it will always have two real roots because we have two sections on this hyperbola. One in the first quadrant, one in the third quadrant. So it's always going to intersect twice. Okay. Now, let's look at where k is equal to 0. You see that when k is equal to 0, it intersects with the graph of g at the origin as well, since the graph of g intersects the origin. Okay, so it has a root at 0. Okay, I'm referring to these x values that it has roots at. It has a root at 0 and then some positive x value here. Okay, if you line that down, it's a value greater than 1 over there. And let's say we had to take this. So this is where k is equal to 0. Let's say we had to increase k. K is the y-intercept, by the way. So if we increase it, and let's say we push it up to like 1, look at what happens. Look at the points of intersection now. It has 1 over here, so that's a negative root. It has 1 over here, that is a positive root. That's what we want. We want roots of opposite signs. Okay, let's keep moving it up and see what happens. You keep moving it up. You see that there we have a negative root and a positive root. And we keep moving it up, negative and a positive root. Now you're going to have to see what this graph of g does as it gets closer and closer to that asymptote. Okay, so we move this up, we keep moving it up. And let's just look at what happens at this point. You see how it's really close to that asymptote, but it's still going to have a positive root and a negative root. This one we can see it's always going to be negative if you keep moving this graph up. But do you see what happens here? Because of this asymptote and the fact that it will stay where it is, okay, it's still going to be this x value of 1 all through. It's now limiting this graph. It's not going to allow this graph to ever cross over, okay, so that this straight line intersects with it in a part where it has a negative root, okay, a negative x value. That will never happen because of this asymptote that is limiting it, that is stopping it. So it's always going to have a positive root. The point of intersection will always have a positive x value on this side, okay? As this graph moves up and this is just moving closer and closer to its asymptote. Okay? It will never go past this 1. Okay, so it's going to always have intercepts for values that are greater than 1, x values that are greater than 1. But what is the value of k for which this happens? So we can see that it meets this criteria all through. A positive root and a negative root. What was that k value? We started at k equals 0, and we saw that as we increase the value of k equals 1, k equals 2, 3, and just increase it, even like in between numbers. As we increase it, it keeps working. So we can see that it works for values of k that are greater than 0. Let's hold on to that. Now, let's see when we make k less than 0, what happens? Okay, there's already a problem here. You see, when k is equal to 0, right? Look at the intercepts that it has. Look at the roots it has. It has a root at 0. It has another root at whatever that is. It's a value greater than 1. That's already not meeting the criteria. We want them to have opposite signs. 0 is not a positive nor a negative number. Okay, so it already doesn't meet this criteria. And the minute you move it down, look at what happens. It intersects over there. That is a positive root, okay? That value is greater than 0 on the x-axis. It intersects at a positive value over here, and it's also intersecting at a positive value over here. That's not what we want. So those have the same signs. And so, because of that, we can finally tell them that this works only when k is a value greater than 0. And that is our answer. And that is it for question 4. Question 5 says the graph of h of x is equal to a to the power of x, where a is greater than 0 is sketched below. And then we have a point, -1.5 is a point on H. So 5.1 says, write down the coordinates of Q. So do you see that Q is the y-intercept of this graph? So at the point Q, this is where x is equal to 0. We can simply take the equation of h of x as it is, as h of x equals a to the power of x. And because Q is the y-intercept, this is the point where x is equal to 0. So in place of x, we say 0, so a to the power of 0. Anything to the power of 0 is equal to 1. So therefore, Q is simply 0 and 1. And that is our answer. Moving on to the next question. Question 5.2 says, determine the value of a. So to find a, okay, we can use this point on the graph. So we have the equation and a is the only thing missing. So we'll write this as h of x is equal to a to the power of x. And then we'll substitute that point p, which is -1 and a half. Okay, so this goes in place of x, and that's y. So y is a half is equal to a to the power of -1. And great, we can actually rewrite a as a fraction because its exponent is negative. So currently it's in the numerator. When you move it to the denominator, it will cause its exponent to become positive. So this is 1 over a to the power of +1 is equal to a half. And then straight away we can see that a is equal to 2. Okay, you could also done this. You could have written the 2, brought the 2 up to the numerator. And so it will be 2 to the power of -1 is equal to a to the power of -1. And you can see that the bases are the same. So again, a would still be equal to 2. Okay, and that is our answer. Moving on to the next question. The next question says, write down the equation of the inverse of h in the form of y is equal to. So the equation of h is currently h of x is equal to, and we found a to be 2. So this is 2 raised to the power of x. And so you can just rewrite it as y equals. And now to find the inverse, we need to switch x and y. So swap x and y, meaning y becomes x and x becomes y. And now how do we make this exponent of y the subject? We can do that using log. So we'll say y equals log, and the base is 2, and that answer was x. And this is our answer. Moving on to the next question. The next question, 5.4, says, sketch the graph of the inverse in your answer book, clearly showing all the intercepts with the axes. Okay, so let's put down a Cartesian plane first. And looking at what the original graph looked like, remember that this is where it has the y-intercept of 1. Okay. Now you see, in the same way that we switch x and y to find the inverse equation, it's the same way that all the x values of this graph becomes the y values of the inverse, and the y values become the x values. So we can look at these 2 points that we have, p and q. So p is -1.5. On the inverse, this point is going to be a half and -1. So if we go a half and -1 will be around here. And so this is our new point. I'll call this p prime. And so that is a half and -1. And then this point that we have, q, it is the point 0 and 1, a y-intercept. Now on the inverse, it's going to be an x-intercept, okay, because these will switch places. They'll become 1 and 0. And so that's an x-intercept. So here we'll have 1 and 0. 1 and 0 will be about here. Okay, so that is q prime. And so that's 1 and 0. And now we can sketch our graph. Now you can compare it to what this graph looks like. If we know now that this graph does this, you see that it has positive y values all through, right? So because it has positive y values, it means that on the inverse, it's going to look the same way this does, but with positive x values like that. So this graph comes from the x-axis being negative, okay, and it's closer to that x-axis at this point, and then it starts to increase and shoots up. So it will do the exact same thing, but on the y-axis instead. So with the negative part of the y-axis, this is where it's going to be closest to the asymptote, and then it's going to start increasing and shoot out like that. Okay, so now let's just go ahead and draw that there on our graph, and we can see how these points align with that. So it's simply just going to do this, cross here like that, and shoot out. So that is the inverse. This is the inverse of h, and that is our answer. Moving on to the next question. Question 5.5 says, write down the domain of the inverse of h. So we can just look at this graph, and we can see, remember that the domain is all the possible x values of this graph. So let's look at the x values that this graph has. You can see that over here, and we can focus on the x-axis. Okay, this part of the x-axis, the negative part, there are no x values. Okay, it only starts at values that are after 0. And the reason why is because you see how this had a horizontal asymptote at y equals 0. Okay, so on that x-axis, then this will have a vertical asymptote at x equals 0. Okay, so it means that it's not going to touch the y-axis, but it's going to move closer and closer, meaning all the x values of this graph lie where x is greater than 0. As we can see, it only has values that are greater than 0. Okay, this is where the graph is. Okay, so that is our answer. Moving on to the next question. And then question 5.6 says, hence or otherwise determine the value or values of x for which log of x to the base of 2 is greater than 1. Okay, it's just the way it has been written here. But with this, you can see that this right here is the equation of our inverse. Okay, if this is the equation of the inverse, then they're just asking, where is the y values, where are the y values of the inverse greater than 1? And that's really all they're asking for. So let's see. This is our inverse. Where's it greater than 1? Now, when they say in greater than 1, this is referring to the y values, okay? Because this is the y values of it. This represents all the y values. So where is it equal to 1? Okay, it'll probably be somewhere up here. Okay, we knew what that was on the original one. Okay, where it was equal to 1 was over there in the y-intercept. But where will it be greater than 1? So we could just draw a line here, and we can first find out what is that point at which the y value is equal to 1, and then we'll be able to tell them all the values of x for which this graph is greater than 1, where it has y values greater than 1. You can see that this will line to these values on the graph of h. These values are values of the graph that are greater than 1. Okay, so let's find out where the y value is equal to 1. Okay, so we're just trying to find out where the inverse of h has a y value equal to 1. So this is the inverse of h, and we're just saying log x to the base 2 is equal to 1. And let's rewrite it in exponential format so we can see this. So in exponential form, this is where we'll have our base, and then what it's equal to, that is our exponent, okay? Because log makes that exponent the subject. So this is to the power of 1 is equal to, and then that would be the answer to the exponential expression. So this is where x is equal to 2. We can see that now. Okay, so where is it greater than 1? It's first equal to 1 at x equals 2, and then we can see that it has y values greater than 1 for values that are all through here. If you map these down to the x-axis, you see that these are values that are greater than 2. Now notice they didn't ask for values that are greater than or equal to 1, just greater than 1. So therefore we can tell them this is where x is greater than 2, and that is our answer. Moving on to the next question. And 5.7, the last question for question 5 says, if g of x is equal to 100 multiplied by 3 to the power of x, calculate the value of x for which h of x is equal to g of x. Okay, so remember that h of x is 2 raised to the power of x. So we're just equating these two. So this is where 2 raised to the power of x is equal to 100 multiplied by 3 raised to the power of x. So we just have to solve for x in this equation. Okay, notice how this is raised to the power of x, and this is also raised to the power of x. So we can just ensure that they are together. So we can divide both hand sides by 3 to the power of x, And now we have, now with this, you see they both have an exponent of x, the same exponent. So we can rewrite this as 2 over 3 all raised to the power of x. Because if this x was applied to the numerator and denominator, it would end up looking like that. Okay, so simplifying it like that, these cancel here and is equal to 100. Okay, and here we can just use log. So x is equal to log, and our base is 2 over 3. And then we have 100. And let's just find the value of x. Okay, rounded off to 2 decimal places, this is negative 11.36. And that is our answer. And that is it for question 5. Question 6 says, the graph of f of x is equal to negative square root x for where x is greater than or equal to 0. So you can see this is the inverse of a parabola, and it has been restricted so that it is a function. So it's sketched below, and the point P, which is 3 and negative 9, lies on f. And the first question, 6.1, says, use the graph to determine the values of x for which f of x is greater than or equal to negative 9. Okay, we're just using the graph, so we're interpreting from the graph. This is the point P, 3 and negative 9. So this is the point where the graph of f has a y value of negative 9, and the x value belonging to that is 3. So where is it greater than or equal to negative 9? So that would be all through here. This is where it has y values that are greater than or equal to negative 9. And so we just have to tell them the values of x for which this section exists. If you line it up to the x-axis, you see that its values starting at 0 and then ending at 3. So these are where we can just tell them this is where x is greater than or equal to 0, because remember, it needs to be a value that is either greater than or equal to negative 9. 0 is greater than negative 9. So this is included. And then less than or equal to 3, because at 3 we have a y value negative 9. So it's equal to negative 9. And that is our answer. Moving on to the next question. Question 6.2 says, write down the equation of the inverse in the form y equals, but you need to indicate all restrictions, and they emphasize all. Okay, so let's take the original, and we need to find the inverse from this. So the original is f of x is equal to negative square root 27x. Okay, we can just call it y is equal to, so we can already work on switching x and y. So this was the equation specifically where x is greater than or equal to 0. This was the domain of this original function. To find the inverse, you have to swap x and y. So we're going to say x is equal to a negative square root 27y, and now we can make y the subject. Now at this point, this is already the equation of the inverse because x and y has been swapped. The only thing we have to do is just make y the subject. Now we need to make sure we indicate all restrictions. So here, when we said y is equal to, and this is the function we have, we defined what x was. Okay, it's greater than or equal to 0. This is already the inverse. But because x is the subject, we need to define y. Okay, so what is the range? This is the inverse itself already. So what is the range of the inverse? Okay, so the range of the inverse, looking at it like this, okay, if the domain was x is greater than or equal to 0, then here's what happens with the domain and range. And I'm just going to put it on the side. You see, with the original function and the inverse, the domain and the range, just like the x and y values swap, the domain and range will also swap. You see how the domain of the original function we had was x is greater than or equal to 0. This means that the range of the inverse will now be y is greater than or equal to 0. So that will be our range here, okay? So we are saying x is equal to, and then we need to define y. So this is where y is greater than or equal to 0. That's where we get it from, because this is the inverse. We have swapped x and y already. And now let's make y the subject of this equation. Okay, so making y the subject, you're going to have to square both hand sides of the equation because this is under the radical. So when we do that, we get x squared is equal to, and this, it will break open. But of course, that negative will also become positive. So now we have 27y, and then to make y the subject, divide both hand sides of this equation by 27. So y is simply equal to x squared over 27. Okay, now we're saying y is equal to, so we need to define x. So x will be, just tell them what x is. This is the inverse. What is the domain of your inverse? So you have to look at that from the graph now, because the domain of the inverse is going to be whatever the range of the original was. So let's look at the range of the original. This is our graph. Domain was where x is greater than or equal to 0. And the range is where y is less than or equal to 0. Do you see that this graph only has y values less than or equal to 0? So that's the range of the original. So if this is the range of the original, y is less than or equal to 0, this means that the domain of the inverse is x is less than or equal to 0. You need to remember this relationship between the original and the inverse, okay? So that's what this is going to be. We're going to say where x is less than or equal to 0, and this is our answer. Moving on to the next question. Question 6.3 says, sketch the graph of the inverse in your answer book. Indicate all intercepts with the axes and the coordinates of one other point on your sketch. Okay, so it will be best to plan this graph out using this graph, so you can understand what the inverse will look like. Now, we've already spoken about something that will help here, and that is this information. So I'm going to keep this here as well. We're going to need this. Okay, so I've pinned it to the screen, and let's look at it like this. You see, this is the original graph, right? Now the inverse, we can already see what the domain and the range of the inverse are going to look like. So the other point they're asking you to put down is this point that we have here. If this is 3 and negative 9 on the original, what will it be on the inverse? It would be negative 9 and 3. So we can actually just put that down and say that this is another point P prime, negative 9 and 3, because the x and y values will swap. And now we can just use the domain and the range of the inverse to figure out how to draw this graph. So it's really just a restricted parabola. So we have that x is less than or equal to 0. That's the domain of the inverse. Okay, if it's x is less than or equal to 0, this is where x is less than or equal to 0 on the Cartesian plane. And the range is where y is greater than or equal to 0. So y is greater than or equal to 0. And you see how that fits perfectly with where this point is. Okay, so it means that your inverse is just going to do exactly what it's doing here, but the x and y values switch places. So think about what this one would have looked like if it was a full graph. Okay, if it was a full graph, it would look like this. And that would be what this graph would look like. So with this one, you see what it's doing on the x and y axis. On the y axis, this is where it has its turning point, right, at 0. And then it shoots up towards the positive part of the x-axis. It's going to do exactly the same thing, but with the y-axis here instead. So here, it's concave up towards the positive part of the x-axis. Here, it will be concave up towards the positive part of the y-axis. So it ends up looking like this. The other wing would look like that. But now to decide which one to keep, okay, that would be your domain and your range. That's what would help you with that. So it's specifically where x is less than or equal to 0. So it can't be this one, because this is where our x values are greater than or equal to 0. So it means that it's this part. And of course, you see the range corresponds with that. So this is where our y values are also greater than 0. These y values are all positive y values. So it's not this one, it's this one. So we're just going to sketch that down. It's always good to plan it out, just so that you don't make any mistakes with that. And that is what our graph of the inverse basically looks like. Okay, so that is it for question 6.3. Moving on to the next question. Question 6.4 says, describe the transformation from f to g if g of x is equal to the square root of 27x. Okay, so you see how the original f of x was equal to negative square root 27 and then x. And now this has been transformed to g of x is equal to the square root of 27x. So what changed? Here we had negative, here we had positive. So clearly we multiplied, we took the graph of g of x, right? And we said it's equal to, we take the graph of f and we multiply its y value by -1. That's what we did. This is the transformation if you're writing it mathematically, but you need to describe it, meaning describe it with words. So what does this mean? Okay, if you apply a negative, you multiply a negative to the y values of a graph, what you are doing is you are reflecting it. Now you are applying that negative to the y values. If you apply a negative to the y values and they all become negative or they change signs, okay, from what they used to be, then all those y values multiply by -1. And what that means is that you reflected it through the x-axis. Okay, so it was reflected about the x-axis because here, it could be a point 2 and 1 again. Okay, and then if you reflect it, it becomes 2 and -1. So the y values change, meaning it's a reflection in the x-axis. So we can finally just conclude it's a reflection through or about the x-axis or even in the x-axis. You can say it like that. Okay, so in conclusion, f was reflected in the x-axis to obtain g. And that is it for question 6. Question 7.1 says, at what annual percentage interest rate, compounded quarterly, should a lump sum be invested in order to double in 6 years? Okay, so we want to find out at what annual interest rate this should happen. Okay, so we can see that the money, right, that we're referring to is doubling, meaning it's growing. And this is compound interest. So this is compound interest growth, and the formula is A equals P times 1 plus I raised to the power of n. So the final amount is, because this money doubles, we can just call the investment, right, the money that goes in, call that x. And because the final amount was double, we can call that 2x. And we're saying multiply by 1 plus. Now the interest, that interest is compounded quarterly. So we can say that interest, okay, divided by 4 because we need to cut it into 4 quarters. And then it's going to be invested for 6 years. But this is 6 years and we need to convert this into quarters. So 6 times 4. Okay, and all we're doing here is solving for I. Okay, so we can go ahead and just get rid of this x by dividing both hand sides of the equation by x. You can divide by x here because x is not 0 and amount was invested. So this will give us 2 is equal to, and that cancels that x out, and we have 1 plus I over 4 raised to the power of 24. Okay, so to get closer to this I, we can just get rid of this exponent of 24. And we can do that by finding the 24th root of both hand sides of the equation. So it means that over here, this will break open and we're left with that 1 plus I over 4 is equal to, and here we just have the 24th root of 2. You don't have to consider any negatives here, even if this is an even number, because we're working with interest. And then if we transpose this one, it's I over 4 equals the 24th root of 2 minus 1. And now we can get rid of the 4 in the denominator by multiplying both hand sides of this equation by 4. So what we have now is that the interest is equal to 4 multiplied by the 24th root of 2 minus 1. And let's just put this on our calculator. Okay, so this is 0.1172. Now we have to present this as a rate. So make sure that you multiply your final answer by 100. And then there we go. So we can finally tell them, okay, answer their question, the annual percentage interest rate. So we can tell them that that annual rate is 11.72%. Okay, and that is our answer. Moving on to the next question. Question 7.2 says, Simon buys furniture to the value of 10,000 Rand. Okay. He borrows the money on the 1st of February 2020 from a financial institution. Okay, let's just record this on the timeline. He borrows this money on the 1st of February 2020 from a financial institution that charges interest at a rate of 9.5% compounded monthly. He agrees to pay monthly installments of 450 Rand. So you see, paying back, borrowing money. This is a loan. So we're using present value. And he's agreeing to pay back 450 Rand, okay, as his monthly installments. So you can already see that the monthly installments X in your present value formula, that is 450 Rand. And the agreement of the loan allows him to pay equal monthly installments from the 1st of August 2020. So 1st February, he gets this loan and he's allowed to start paying back on the 1st of August 2020. And 7.2.1 says, calculate the total amount owing to the financial institution on the 1st of July 2020. Okay, so let's speak about how loans are paid back. You go to the bank, you borrow, right? You don't start paying back on the same day. You start paying back a month later, depending on the compounding. Okay, so if you're paying back monthly, then you're going to start paying back 1 month later. If you were paying back quarterly, you pay back 1 quarter later, okay, and so on. So naturally, he's not supposed to start paying back on the 1st of February. He's supposed to start paying back on the 1st of March. But we know that he starts paying back on the 1st of August. So the question is, how much does he owe on the 1st of July? Because this is how his timeline is going to be adjusted now. Since this is where he's going to start paying back, they will determine how much he owes a month before this. Okay, so they're going to determine how much he owes on the 1st of July, and then on the 1st of August, he starts paying back. This is because the loan amount is determined a month before the first payment starts. Just like here, had he not defaulted in these payments, had he not had delayed payments, he would have started paying back 1 month later. So since he's paying back on the 1st of August, we determine how much he owes a month before this on the 1st of July. Okay, so looking at it like this, we're going to determine how much he owes from here. So from February to July, how many months is that? That's March, April, May, June, July, 5 months. Okay, so it means that these payments were delayed by 5 months. That money that he owed 10,000, it's not going to be 10,000 anymore. It's going to grow by 5 months that he still owed it. And that's how loans work. You're going to always pay interest on what you owe. So this is A is equal to P times 1 plus I raised to the power of N. And so we are growing 10,000 Rand. We'll say 10,000. 1 plus the interest is 9.5% compounded monthly. So it is 0.095 over 12 raised to the power of 5 months. Okay, you do not have to multiply this by 12 because this is already months. Okay, we multiply by 12 to convert it into months to ensure that this interest is being applied monthly for every month. Okay, so there we go. So this is A is equal to, and let's just find our answer. And our answer is 10,402 Rand and 15 cents. So that is exactly how much he will owe on the 1st of July. Okay, moving on to the next question. Okay, next question. How many months will it take Simon to repay the loan? So they want to know the months it will take to repay the loan. This is still present value. We now know how much he owes. This amount is now your new present value. It's not 10,000 anymore. He doesn't owe 10,000. So to find out how many months, we're going to use the present value formula, which looks like this. And let's fill in our values. So he now owes 10,402.15 is equal to, and we know how much he's paying back every month. He's paying back 450 Rand per month. So we'll say 450 and then 1 minus 1 plus the interest is 0.095 over 12 raised to the power of, and that's what we're going to leave empty. So it's raised to the power of negative n because we need to find out how long it's going to take him to pay back this loan. So all over the interest, which is 0.095 over 12. Now notice how I'm not multiplying this by 12 because it's not necessary in this case. And the reason why is because you see how we always take whatever the years were. Let's say he has to pay this loan back in 3 years, right? Would have said 3 multiplied by 12, and then that would give us 36. And then we just keep using 36 like that. So I'm seeing it like that. I'm not going to multiply by 12 because I don't want to end up trying to divide both hand sides by 12 at the end of the day. I'll just take whatever number I get here, and that would be my months. Okay, so all we're just doing here is simplifying, okay, and solving for n. So how can we simplify this? I'm going to try to do this in a way that avoids decimals. So it's going to be a lot of rewriting of the numbers that are there, but it's fine because you'll always be able to keep track of your calculation. And if you go wrong, you can always check back because the numbers still look the way they originally looked. Okay, let's go. So we can go ahead and get rid of this denominator first by multiplying both hand sides of this equation by this. So if we multiply by 0.095 over 12 on both sides, so we can just leave it as it is, 0.095 over 12 multiplied by 10,402.15 is equal to, and now this is gone, and all we have is that 450 there. So rewrite everything. So the next concern becomes this 450. Well, we need to get rid of it so we can get closer to that exponent. Because it is multiplying by everything here, to get rid of it, we can divide both hand sides by the 450 to get it out of there. Okay, so like that. And now the 450 is gone. So we'll just have everything else excluding the 450. So the bigger bracket is now gone, and this is what we have. Now, at this point, you can use this as an opportunity to convert this into a fraction. So let's find out what 1 plus 0.095 over 12 is as a fraction. You can leave it as a fraction because it'll just be easier to work with since it's our base in this case. So we'll call it this number. So that is 1 minus, we'll say it equals 1 minus 2,419 over 2,400, and it's still raised to the power of negative n. Okay, and then we'll still have all of this just written here again. Okay, and one more time with just the rewriting. Do you see that all of this, right? This, it is negative. It has a negative in front of it. So to make it positive, so we can easily solve, we can just transpose it. So now it's positive 2419 over 2,400 raised to the power of negative n. And this is equal to 1 minus everything we have here. And now we can get substituting. Okay, so the benefit of this is you can at least see if you've gone wrong somewhere. You can always backtrack from here. So this is to the power of negative n is equal to, and let's put this on the calculator. So this is equal to, as a decimal, it is 0.81699992, and I'm not rounding off yet. And now we can finally solve for this negative n. So we'll say negative n is equal to, okay, and we're going to have to use log here when we make the exponent the subject. So we'll say log, and our base is 2419 over 2,400, and the answer, okay, that was equal to 0.8169, and then that kept going. And let's find out what this is on our calculator. So negative n is equal to, and our calculator, just make sure that that is recorded. So you're going to say log, and as the base was saying 2419 over 2,400. And then here we're just going to say ans because it has been recorded in the answer. And there we go. Do you see what we have? We have negative 25.6315. And of course that continues, but then just multiply this by negative 1 so that you can get it to be positive. So n is finally equal to positive 25.6315. That keeps going. Now, let's just see what the question specifically said. It said, how many months will it take Simon to repay the loan? Okay, so looking at this, if you say it takes 25 months, that's not true. Because of this 0.631512, you see, this is still a payment that you have to make. It may not be one single payment, like and equals one month. It's not 1 month, but it's less than a month's worth of payment to make. So the total months it will take for him to actually pay off the loan completely would be 26. So 26 months. And you can conclude it will take him 26 months to repay this loan, but this is fine. Okay, so that is it for that question. Moving on to the next question. Question 7.2.3 says, what is the balance of the loan immediately after Simon has made the 25th payment? Okay, so it comes from this. You see, at the 25th payment, what he has left to pay, okay, the amount of time left to pay is that 0.6315 payment, okay? So that would be the amount that we need to substitute because that's the remaining payment that is still there. So we're trying to see how much that payment is. And you'll see he owes something. It may not be that full monthly installment of 450, but it will be an amount less than it. So we're going to use our present value formula for this because the present value formula will always tell you how much you owe after a specific amount of time has passed. So we need to find out after the 25th payment, we know he has this more left to go. And so in place of n, that's what we're going to substitute. So we're taking this present value formula, but in place of n, we're going to substitute this amount, which is 0.6315, okay? And let's just take that full amount. So present value is equal to, and remember present value is empty because we're trying to find out how much is owed after the 25th payment. You always say the amount owed by present value. So this is 450, and then 1 minus 1 plus, the interest is 0.095 over 12 raised to the power of, and this is going to be negative 0.6315, okay, don't round off, and then all over I, which is 0.095 over 12. So let's find out what this will be. Now on your calculator, you need to decide because you already have this number recorded here. You see that this is negative 25 and this needs to be negative 0.63. So it's going to still stay negative if I simply just add 25 to this number. So as it is like this, if I just say plus 25, do you see that's the number that we're looking for? So I'm going to use that number. So I'll say it's equal to, I have to say equal to on my calculator first. And then let's put the fraction, put in our values. And in place of negative 0.63, we'll just say ounce because we know it's recorded there. Okay, so at this point, you say raised to the power of and you say ounce. And it's going to record that answer, close your bracket. And there we go. So the amount owed immediately after that 25th payment would be exactly 282 Rand. And it's going to round up to 36 cents. And that is our answer. Okay, and that is it for the financial math section. Question 8.1 says, determine f prime of x from first principles if f of x is equal to 3x squared plus 2x. So using first principles, we know that we need this f of x plus h. So let's get that first. So it's f of x plus h, meaning wherever you see x, replace it with x plus h. So this is 3, and there's x. So it's x plus h all squared plus 2, and again, x plus h. Okay, let's simplify. So this is going to be 3 multiplied by, and we will square the first term, giving us x squared, square the last term, giving us positive h squared, and then first term times second term is xh, and then multiply by 2. So this is positive 2 xh. Okay, and then we have, if we distribute in here, that is positive 2x plus 2h. Okay, and now we can also just FOIL in here as well. So this is 3x squared plus 6xh plus 3h squared plus 2x plus 2h. And that is f of x plus h. And now we can find f prime of x from first principles. So this is our formula. F prime of x is equal to the limit as h approaches 0, and it's f of x plus h minus f of x over h. Okay, so this is equal to the limit as h approaches 0, and f of x plus h is all of this that we just found. We've already expanded it. And we're going to subtract this by f of x. Now, you can choose to say minus and then put a bracket so that it applies to both terms, but we could also just see this as distributing it in. So if we're saying minus f of x, we're saying minus the 3x squared, so that's minus 3x squared, and minus the positive 2x, so that's minus positive 2x. Okay, it's going to multiply in there. When we say minus that, it distributes. Okay, and all of this will go over h. So this is equal to the limit as h approaches 0. And what will cancel here is whatever you were subtracting by. So 3x squared cancels with negative 3x, and then the 2x with the negative 2x. And then at this point, you can just take out your common factor. So the main problem is that h is in the denominator. So we can't find the limit at this point, because if we substitute 0, if we evaluate this, it's going to become undefined because your denominator is going to be 0. So what we're just going to do is take h out as a common factor, so it solves that problem. And now what are we left in this term when h is out? You're left with 6x. And in this term, we're left with positive 3h. In this term, we're left with positive 2. And this goes all over h. And then h cancels, and now we have, you can choose to substitute at this point, but I'm just going to write it for the last time. F prime of x is equal to the limit as h approaches 0, and we have 6x plus 3h plus 2. And now we can substitute. So it means that f prime of x is equal to 6x plus 3 times 0 plus 2, and therefore f prime of x is simply equal to 6x plus 2. And that is our answer. That is the gradient of this function at any point. Moving on to the next question. The next question says determine dy over dx. So we need to determine the derivative in respect to x of this function. Okay, let's just rewrite it first, just to analyze what's going on. We've got a square root of x. Okay, that's a problem. We have x under a radical, so we need to fix that. And then we have x under a radical, but it's also in the denominator. So minus 8 over the square root of x. And then plus pi x cubed. And this is fine. Pi is a number, so that's fine. Okay, so we can just say y is equal to, and we have 4. And with the x, we're going to rewrite this so that it has a base and a rational exponent. So the base is x, and the exponent is going to be the inside exponent, which is an invisible 1 on top of the x, and the outside exponent, which is a 2, because we have this root. This is a square root, okay? So it's going to be 1 over 2, and then minus 8, and now we have the square root of x. If you first rewrite that as x raised to the power of 1 over 2, and then you move it to the numerator, you'll see that the exponent will become negative. So it shouldn't be in the denominator. Okay, so we'll move it up to the numerator, and so it becomes negative 1 over 2 as the exponent. And then this is fine. There's nothing wrong with this. And now we can go ahead and derive. So dy over dx is equal to, and we're saying coefficient times exponent, which is 2, and then x, exponent minus 1, which will be negative a half. Coefficient times exponent, that's going to be positive 4. X, exponent minus 1, that will be negative 3 over 2. And then coefficient times exponent, that's going to be positive 3 pi. And then x, exponent minus 1, which is 2. Okay, pi is a number. So we're saying that number times 3 is 3.14, and then keeps going. It's still a number. Okay, and then at this point, you can leave your answer like this. You can choose to also rewrite these bases with positive exponents as well. Okay, moving on to the next question. Question 8.3 says, the graph of g of x is equal to ax squared plus b over x is equal to 96. has a minimum value at x equals 4. Okay, so from this question, you can already see that the way certain things have been named, okay, could be misinterpreted. And you would also notice that in the memo, they actually removed that question. So it's for 0 marks now. But we're still going to practice using this question. And this is how it works. So the graph of G has a minimum value at x equals 4. Do you notice how they say g of x and then they put down what g of x is equal to, and then they say is equal to 96. So that is actually the y value of this graph at this point where it has a minimum. So when we say a graph has a minimum, right, we're just saying, for example, if you have a parabola, this is the minimum value of this parabola, meaning we are pointing at the turning point. And we know what happens at the turning point. The gradient of this function is equal to 0. Okay, so they want us to calculate the values of a and b. Okay, so at this point, you would probably notice that in order to find two missing variables, you need two pieces of information or two ways to form two equations. And they've actually given us this. So they told us that this graph has a minimum at x equals 4. So it means that we have this graph g of x, and at 4, right? And the y value that corresponds to this is 96. That there is a minimum at this point. So it means that we have the coordinates of x and y, and we also know that at the point where x is equal to 4, the gradient of this function is equal to 0. In other words, when we find g prime of x, and then you substitute 4, that gradient is equal to 0. So these are the two pieces of information we have. We have the information about the gradient of this function, and we have information about a point on this graph. And it is just enough to find the values of a and b. Let's go. So we can start by substituting this in place of x and y. So we're taking g of x being equal to ax squared plus b over x. And the x value is 4, so it's g of 4. And the y value is 96. So 96 equals a multiplied by 4 all squared plus b over 4. And if you simplify this further, you see that we can actually make b the subject here. We can make b the subject by multiplying both hand sides by 4, but let's just simplify first. This is 96 is equal to 4 squared is 16, 16a plus b over 4. And so to get b on its own, let's just multiply both hand sides of this equation by 4. Okay, so what is 96 times 4? It is 384. So this is 384 is equal to, and if we distribute, 16 times 4 is 64. So that's 64a plus b, okay, because the 4 will cancel. And now that b is without a denominator, we can leave it as b is equal to 384 minus 64a. Okay, and this is our first equation. Now to find the second equation, we'll use the information about the gradient. So to find the gradient of this function, we need to derive it. But currently it's not ready to be derived. So let's prepare it by taking that denominator of x to the numerator. So now we have g of x is equal to ax squared plus b. And then if we move it to the numerator, it will cause its invisible exponent of 1 to become negative. And now we have g prime of x is equal to coefficient times exponent is 2ax. And then exponent minus 1 is 1. Then coefficient times exponent is negative b. And we have x, exponent minus 1 is negative 2. And we're going to substitute the x value of 4 in here. So we're saying g prime of 4 equals 2a times 4 minus b times 4 raised to the power of negative 2. And we're specifically saying that g prime of 4, the gradient where x is equal to 4, is 0. So 0 is equal to, and 2 times 4 is 8, so this is 8a, and then minus b, and this is 4 raised to the power of negative 2, which you can rewrite as 4 squared, okay, moving it to the denominator, and then the exponent becomes positive. 4 squared is 16, so this is what we have, and now we can just make b the subject. So transpose it, it's b over 16 equals 8a, and multiply both hand sides by 16 to get b alone. So b is finally equal to 8 times 16, that is like 8 times 8 is 64. And then times 2, 64 times 2 is 128. So this is 128a. And this is equation 2. Okay, so we've got equation 1 and equation 2. They're both in terms of b. Don't even have to call it that. We can just say b is equal to b. And so 128a is equal to 384 minus 64a. And now we're just solving. So we can transpose that 64. 128a plus 64a is equal to 384. Okay, 128 plus 64, that is already a 12. That's 8. 92, 192. So 192a is equal to 384. And then we can divide both hand sides by 192. 192. And let's find out what a is. So 384 divided by 192 is 2. So a is simply equal to 2. And now with this, we can find b. So use the easier equation. You see b is equal to 128a. So we just say b equals 128 multiplied by 2. And so b is equal to 28 times 2. That is 56. So this is 256. And that is the value of a and b. And that is it for question 8. Question 9 says, the graph of h of x is equal to negative x cubed plus ax squared plus bx plus c is sketched below. And we have a and b, which is 6 and 0. Okay, so this is 6 and 0. These are turning points of h. And then they tell us that t is this point 3 and y. So it just has the y value missing. And it's a point on h. The graph of h passes through the origin. Okay, so that should tell us something. If it passes through the origin, then it means it has a common y and x-intercept here. But that still means the y-intercept is equal to 0. Okay, let's keep that in mind. And 9.1 says, show that a equals 12 and b equals negative 36. Okay, so the equation we have, you can see that we have a, b, and c. But we know that this is the origin and the graph passes the origin, meaning that c, that y-intercept, is equal to 0. That is the y-intercept over there. So we can just state that first. C is equal to 0. And so our equation is now h of x is equal to negative x cubed. And that was plus ax squared plus bx. So plus ax squared plus bx. So we have to find two missing variables given what? So the only complete point here that they have given us is this point b, 6 and 0. There's no other point that is complete. We don't have this. This is just 3 and something else. So we can only use 6 and 0. But think about what 6 and 0 is. 6 and 0 is a point, specifically an x-intercept, but it's also a turning point. So this information can be used twice. And this is how we're going to do it. So we're first going to use it as a point, using 6 and 0. And then we'll use it as a turning point. So as a turning point, remember that at that point, okay, of 6 and 0, this is where the gradient of this function is equal to 0. Okay, the gradient of the graph of h at x equals 6 is 0. So we'll use it like that, meaning we will use it as h prime of 6. Okay, so the gradient of the function at the point where x is equal to 6, that gradient is equal to 0. And these are the two ways we can use it to find a and b. So the point 6 and 0, we're just going to take this as a point and substitute it in place of x and y. So we're saying in place of y, 0 equals negative and x is 6 all cubed plus a times 6 all squared plus b times 6. Okay, so 0 is equal to 6 cubed is 216. So this is negative 216. And then this is positive 36a and plus 6b. Okay, so we can just make 6b the subject since they are all divisible by 6. So we'll transpose these two. And so we have 216 minus 36a is equal to 6b. And they're all divisible by 6. So if we divide both hand sides of this equation by 6, b is equal to this divided by 6, okay, if you say 6 cubed divided by 6, that's 6 squared, which is 36. And 36 is 6 squared. So 6 squared divided by 6 is 6. So we have minus 6a. Okay, and this is what we have, and that's our first equation. We'll see if this one can also be written in terms of b. Okay, now we're using 6 and 0, okay, that point, as a turning point. So specifically at the point where x is equal to 6, the gradient of this function is 0. So how do we find the gradient of this function? We find that by deriving it. So we're going to derive h of x. So now we get h prime of x is equal to, and its coefficient times exponent, so that is negative 3x squared, then plus 2ax, okay, and then exponent minus 1, and then plus b, and the x will fall away because exponent minus 1 is 0, anything to the power of 0 is 1. Okay, so this is what we have, and we're specifically finding the gradient of this function at the point where x equals 6. So negative 3 times 6 all squared plus 2a times 6 plus b. And we're substituting in place of this. We're saying the gradient at the point where x is equal to 6 of this function is 0, because we have a turning point there, is equal to, and then this gives us 36. 36 times 3 is negative 108, and then that's positive 12a plus b. And you see how b can also be made the subject here. So let's leave it on the right hand side, and we have positive 108 minus 12a. Okay, great. So we've got b is equal to b, okay, so we can just equate them. B equals b, and we say this is, let's just put it on this side. So b is equal to b, and we're saying 36 minus 6a equals 108 minus 12a. If we transpose the 12, it becomes positive. So it's 12a minus 6a, which is 6a, and then 108 minus 36. And so we have 6a is equal to, that will be 72. And then if you divide both hand sides by 6, a is therefore equal to 12. Okay, so there we go. We've got a. And now b, we can just use the easier equation to solve for b. So we'll say b equals, we have 36 minus 6 times 12. And b is equal to 36 minus, that gives us 72. And then it is going to be, this is double of 36. So this is negative 36. And that is our answer. So a is indeed equal to 12. And b is equal to negative 36. Moving on to the next question. The next question says calculate the coordinates of a. So the coordinates of a. What was a? Okay, a is the other turning point. So just find the other turning point. Now that we have a and b, we can complete our equation. So our equation is now h of x is equal to negative x cubed. And then in place of a is 12, so there's positive 12x squared, and b is negative 36, so that's minus 36x. And now we can find the stationary points, because a is one of the stationary points. So to find the stationary points, again, we're using the idea that we know that at the stationary points, the gradient of the function is equal to 0. So we're going to find the gradient by deriving this. Is equal to, and coefficient times exponent is negative 3x squared. Then we have plus 24x and minus 36. And now we're saying the gradient of the function at the turning point is equal to 0. Okay, so then we rewrite this. And then you see that they're all divisible by negative 3. So we can divide both hand sides of this equation by negative 3. They have a common factor. So therefore, now we have x squared and then minus 8x, and that will give us positive 12 is equal to 0. Okay, factorize, open up two brackets, set it equal to 0. X multiplied by x gives us x squared, and now we need factors of 12 that can give us 8, negative 8 specifically. So because only the middle is negative, it means these two must be negative. So we could use like negative 2 and negative 6, because negative 2 times negative 6 is positive 12, but negative 2 minus 6 is negative 8. Okay, so that is minus 2 minus 6. And so therefore, x is equal to 2 or x is equal to 6. Great. We know the one that x is equal to 6. We know where x is equal to 6. It's at b. We are specifically going to focus on a. So this has an x value of 2, and to find its y value, that corresponding y value, just substitute this x value of 2 into the original equation of h, because this will give you y values specifically for whichever x value you substitute. So in place of x, we'll substitute 2. So like this, and so h of 2 is simply equal to, and we'll just put that on the calculator, and h of 2 is equal to negative 32. So that would be the coordinates of A. We can finally say the x value is 2 and the y value is negative 32. And that is our answer. Moving on to the next question. Question 9.3 says, calculate the value of y. So what is y? And looking at our graph, you see that y is over here, okay? This is where the x value on this graph is 3. So just substitute that x value to get its corresponding y value. Okay, so we'll need the equation of h again, and we're going to substitute the x value of 3. Okay, so we'll say y is equal to, and let's substitute. So y is finally equal to, and this is negative 27. And that's all they asked for, the value of y. Moving on to the next question. The next question, 9.4, says, is the graph of h concave up or down at the point t? Okay, show all calculations. So the point t is that point where x is equal to 3. To find out where it is concave up or down, we can actually see how it's curved. So here we can see that it's concave up, and here we can see that it's concave down. But we can't just say, oh, it's on this side, so it's concave down. We have to actually find out. So how we can find this is by finding the points where the concavity changes. And this is at the point of inflection. Okay, so we find out what exactly that x value is. We will know based on where 3 is, okay, and based on whatever that number is, we will know whether it is in the region that is concave up or concave down. Okay, so with this, we're going to need the shape of that graph. And we have to find that x value of the point of inflection. So you can actually find this because you have the full equation of h. You can find this by finding the second derivative and then setting it equal to 0. But another easy way to actually just do this is just say, find the second derivative and find out where it's concave up. This is where the second derivative is greater than 0. And I can also just see another way to do this just because they gave us these turning points. So you see the turning points, they're very useful. If you find the midpoint of your turning points, those x values specifically, you will find the point of inflection. So the middle of 2 and 6, okay, if you find that, that will be the point of inflection. And the reason why is because this is a cubic function. If you derive it, you get a parabola. So notice that this cubic function had the coefficient of x cubed be negative, meaning when you derive it, it will form a concave down parabola. Now, the thing about this parabola is that at its x-intercepts, it's going to have the same x value as the turning point on the cubic function. Okay, so those would be the exact same x values. And so when we have that, if you took the x values of the stationary points, right, those x-intercepts of your parabola, and you found the midpoint of them, do you see that that will be the turning point of this parabola? So that turning point, that x value, it's going to be the exact same x value as the x value of your point of inflection. So that's the relationship there. So you could either find that x value of the point of inflection by deriving this graph, okay, twice, or you could find it like this. So I could say 2 plus 6 divided by 2. That middle will give us that point of inflection's x value. Okay, so I'm just going to find that by saying this is where x is equal to 2 plus 6 divided by 2. That's 8 divided by 2, which is 4. So x is equal to 4. Great. So now we know that the point of inflection occurs at x equals 4. Remember that your function h looked like this, right? And of course it passed the origin. So because it looks like this, now we know that this is where the point of inflection is at x is equal to 4. Do you see now that all through here, this is where it's concave up. So for values where x is less than 4, that's where it's concave up. And we can actually put that down. We can tell them, we can see that it is concave up. Now I'm just going to actually write the actual words. I don't need to write this. All I would have to say to show them that it's concave up is tell them that the second derivative of this is greater than 0. Okay, this is where it is concave up. It's concave up where we can see that x is less than 4, all through there. And then it's concave down, it's curved down like that, okay, a sad face, where the x values are greater than 4. Okay, if you line these down to the x-axis, these are values that are greater than 4. Okay, concave down where x is greater than 4. So with this, to find out the concavity at point T, remember where T is. T is the point with an x value of 3. So where will it lie here? Is it going to lie before the 4 or after the 4? 3 is before 4, so it's here. So that means that this graph is concave up at T. So T could be like there. Okay, so it is concave up at T. And you can tell them, you just finally conclude the graph is concave up at point T because we can see where that is. And just tell them because we know that 3 is less than 4. So it falls into this category. Okay, so there we go. And I will just leave that along with this graph, just showing where that is. And that is enough of an explanation. Okay, alternatively, you could also just find the second derivatives equation, and then you could take that x value of 3, right? Because we're trying to find out the concavity at that point. And you could just substitute it. You'll see that it will give you a value that is greater than 0. Okay, so that's another way. And that is it for this question. Moving on to the next question. The last question for question 9, 9.5 says, determine the coordinates of the point of inflection. Okay, we already have the x value of the point of inflection. So, and we have the full equation of h. Just substitute that x value of 4 into the equation of h so that you can find its corresponding y value. Okay, so we know that we just have to find h of 4, and let's substitute. Okay, and h of 4 is equal to negative 16. So our point of inflection, we can just conclude, is 4 and negative 16. And that is our answer. And that is it for question 9. Question 10 says, a hotel has 72 rooms to let to clients. The daily rent per room is 500 Rand. If the rent is increased by 100 Rand per day, 2 rooms can be left vacant daily. The rent is X Rand per room per day, where X is greater than 500. And 10.1 says, show that the total daily income, I, is given by I equals this. Okay, so we need to find the total daily income. Let's just see the things they've given us. They've told us that a hotel has a total of 72 rooms to let, okay? And the daily rent per room is 500 Rand. So we have information about the rooms and the daily rent per room. That is 500 Rand. Okay, this is per room. If the rent is increased by 100 Rand per day, 2 rooms are left vacant daily. So let's tabulate this. They've given us information about the rooms and the rent per room. And we know that in total, there are 72 rooms in this hotel. And the rent is 500 Rand per day. So the rent is 500. But here's what happens now. They say that if the rent is increased by 100 Rand per day, 2 rooms can be left vacant. So if this rent goes up by 100 Rand, it becomes 600 Rand, and then 2 rooms are left vacant. 2 rooms are going to be left open, meaning how many rooms will be rented out? 70 rooms will be rented out because 72 minus 70. And then the next day, okay, because it's another day later, the rent will go up by 100 Rand, making this 700 Rand per room that you're going to have to pay as rent in each room. And how many rooms will be rented out? Okay, 2 rooms extra will be left vacant, so there will be 68 rooms. And this pattern will just keep going. And of course, this will be until there are no more rooms to rent, seeing that 2 rooms keep being vacant. Now, they gave us another piece of information that should assist us here, and it's that the rent is X rand per room per day, okay? That the rent is X rand, where X is greater than 500. So it means that the rent that they are referring to, it's not this, okay? It's not on that first day where there are 72 rooms to let and then the rent is 500, okay? It's anything from above here. But we can't really say, oh, it's this one or it's this one, okay? They didn't really specify. So that's probably where we're going to have to find a formula for that, a general formula to tell us that. Okay, and the whole point of all of this is that we need to find the total daily income. Okay, now I see what the income looks like, no problem, but let's just figure out how we would calculate the total daily income first. If we have this situation where we have a hotel, there are rooms to rent, and they are set at specific prices, okay, per day, then how you would calculate the total income, okay, let's just say total income would first be calculated by finding out how much is the room, first of all, so how much is that rent for that day, and then how much rooms did you rent out. So if you find out the total rent, for example, let's say the rent was 600 Rand, but there were exactly 70 rooms, then it means that this hotel made how much? 600 multiplied by 70, right? Now, we would have to take that rent and multiply it by the rooms that have been rented out. And so this would be what we need to aim for. We need to calculate the total income. So we need to find a way to find an expression for the rent and the rooms available. So we're going to have to find a general term that will express the total rooms available and the total rent. That way, when we get them, we would be able to multiply them to get the total income, and they should be in terms of X. Okay, so let's focus on each of these now. Okay, so how do we find the rent? From the way the pattern looks with the rent, do you see that they keep increasing by 100? So this is how we can see it. They did say that X is greater than 500. Okay, that rent is greater than 500. So when we're looking at this pattern, just so that we can find a general formula for the rent pattern, we can start like this. Instead of starting at 500, we can start at when the increases happen. And remember that the increase happened per day. So, for example, this increase would have happened because this is the first day that we had an increase. I can call that day 1. And then the second day that we had an increase, it was 700 Rand. And then there was 68 rooms to rent. So we can just calculate it like this. So the rent as a pattern, it would be the first day of the increase that we saw, right? It was the rooms were 500 Rand per day, but then they increased by 100 Rand on that first day. And then the second day, it was whatever this was, the previous day's rent, plus an extra 100 Rand. And then the third day would be whatever this one was. You see that we have 2 sets of 100 being added. So the best way to put this or represent this would be like this. So instead of writing 100 twice or 100 3 times, we could just write it like this. We could say 500 plus 1 times 100. And then this one can be 500 plus 2 times 100. See, then that represents 500 plus 100 plus 100. And so the next day, the third day's increase would be 500 plus 3 times 100. And so in each of these, we can see that this would be day 1 of the increase, the first day of the increase, second day that it was increased, third day that it was increased. So you see how these numbers now stand for the day of the increase. That's day 1, that's day 2, that's day 3 of that increase. Okay, so this is how we could represent the rent. So it means that as a pattern, you could just represent it like this. We could just say, this means that the rent is equal to, and we'll say 500 plus, now you see it's just 1 times 100, 2 times 100, 3 times 100. So we could just say whatever day it is times 100, which is just 100D. It's like saying 100N, like in patterns. Okay, so that would represent the rent. Now we need a formula as well that would represent the rooms. Okay, so with the rooms, we'll say this is equal to, and let's look at the pattern with the rooms. It's 72 and 70, 68. So we'll start here, and looking at that, how we got 70 in the first place was by saying 72 minus 2. So the first day it was 72 minus 2, okay, because 2 rooms were vacant, so there were only 70 rooms available. And then day 2, it would be 72 minus 2, this, and then minus 2. So 2 extra rooms will be vacant. And then day 3, it would be 72 minus 3 sets of 2s. So do you see that with this pattern, we could just rewrite this as 72 minus 1 times 2, okay? And then you see there are 2 sets of 2s that you're subtracting by. So it's 72 minus 2 times 2. Okay, 2 sets of 2s that we're minusing. And here this would have been minus 2 minus 2 minus 2, which is just 72 minus 3 sets of 2s that we are subtracting by. And this pattern keeps going. So a general term for this pattern, for the rooms, I feel like we should have called the T something, but it's fine. So a general pattern for the rooms, or the rule for the rooms, would be just take 72 minus whatever day that you're on. Because you see that these numbers, 1, 2, 3, they also represent the day of that increase. Okay, this was the first day of the increase. 2 rooms were vacant. Second day of the increase, 2 more rooms were vacant. Okay, so we can call that D as well. We'll just say minus 2D. Okay, because you can see this 1, and that's 2, and that's 3. So that represents D. So D times 2. Because it just keeps subtracting by 2 rooms per day. Okay, so this is what our formula now looks like for the rent and the rooms. But currently they're both in terms of D. Okay, and we would still be okay with that. But looking at the formula, that doesn't have any other variable except for X in it. So let's see how they probably found a value to represent D. And they probably represented it in terms of X, seeing how this is in terms of X. Okay, so we have general terms for these. And we're really just trying to find a general term for the income, the total daily income of this hotel. And now that we have this, because we can see that we just have to take that rent, multiply by the rooms, but they're still in terms of D. Let's go ahead and make D the subject so that we can find D in terms of X. And so we have X minus 500 is equal to 100D. And if we divide both hand sides by 100, then it means that D is simply equal to X over 100. Well, I can just write it as X over 100, or 1 over 100X. And then negative 500 divided by 100 is negative 5. So this is an expression to represent the day. Okay, that specific day they're referring to. So here is what we can do to find the total income. To finally find I, this total income, again, we are going to say this. The total income is found by saying the rent multiplied by the total rooms available to be rented. So this is going to be equal to, and here's the rent. The rent was just 500 plus 100D, but we're going to have to, put that value in place of D. So 500 plus 100D multiplied by, and then the rooms, that was 72 minus 2D. Okay, 72 minus 2D. And you see that all we have to do here is substitute in place of D. So now this will give us I when we substitute in place of D. So this is 500 plus 100, and then let's just multiply D in there. Okay, so you can see that D is X over 100 minus 5. It has 2 terms. So we'll say multiplied by X over 100 minus 5. And then that is on its own, and we're going to multiply this by 72 minus 2D. So that's 72 minus 2 times as well X over 100 minus 5. And all we have to do here is distribute, and you'll see that we will get to their equation as well. So I is equal to, and we have first 500 plus, now this 100 is going to distribute in here. So we have this 100 multiplied by X over 100. You see, 100 is in the numerator, so it's going to cancel with that denominator. And so now we have plus X, and then 100 times negative 5 is negative 500. See that those will cancel. Okay, then we have 72 minus 2 times x over 100. It's 2x over 100, but you see that 2 and 100 have 2 in common. So 2 cancels here and 2 cancels here, giving you 50 here, meaning you have x over 50. So x over 50, and then negative 2 times negative 5 is positive 10. Okay, so finally I is equal to 500 cancels, and we have x, so it's just x, multiplied by 72 plus 10 is 82, and then minus x over 50. And then distribute this. So I is finally equal to, that is 82x, and that is, you see this is in the numerator, so it's x times that x. So it's negative x squared over 50. And that is our answer, okay? Just like they have it as well. Moving on to the next question. Question 10.2 says, calculate the maximum daily income per room. So we have the total income per room. If this is what it looks like, this is an expression to represent it. Okay, so to find the maximum, this is now an optimization question. We're just finding the maximum. Now think about how you find the maximum if you had a parabola, okay? If you had a parabola and you're trying to find this maximum, the highest that this parabola reaches, we can find this because at this point, this is where the gradient is equal to 0. The gradient is stationary, so at that stationary point. So all through the parabola, you see that the graph here is increasing, meaning it has positive gradients. And then here, it's decreasing. You always read it from left to right, okay? So it has negative gradients. So how we will find that is where the gradient specifically is equal to 0. So let's take this equation. For the sake of, deriving it nicely, I'll just call it I of x. Anyways, it is in terms of x. So I of x equals 72x, and let's just prepare it to be derived. Instead of writing this like this, I'm going to write this as negative and then the invisible coefficient of 1. So minus 1 over 50 and then x squared. And now we can derive this. So we're going to derive it so that we can find the gradient of this function. And then we'll set that gradient equal to 0 so we can find the x value at which this has a maximum value. Okay, so let's go ahead. We'll say I prime of x, and we're going to set that equal to 0. So let's derive this, find I prime x. So this is going to be 82 multiplied by the coefficient of 1, which is 82, and then x, and then exponent minus 1 is 0. And then anything to the power of 0 is 1, so this stays 82. Then negative 1 over 50 times 2, okay, negative 1 over 50 times 2 is negative 2 over 50, which is negative 1 over 25. So negative 1 over 25, x, exponent minus 1 is 1, and you don't have to rewrite that. So it's equal to 0, and we just have to solve for x. So let's transpose this to make it positive. We have 82 is equal to 1 over 25x. Now, this x is in the numerator, so you can just choose to write it here, okay, in place of the 1, because it's really x over 1. So 1 times x is x, 25 times 1 is 1. Okay, this is what we have, and now we can cross multiply. So x is finally equal to, so 1 times x is x, and then 82 times 25. And that is 2050, okay? So we have 2050, and this is specifically the x value at which this will have a maximum value. So looking at this concave down parabola, which it is, as you can see, this is a quadratic equation, and we have the highest exponent being x. As you can see, this is a quadratic function, okay, and the highest power is 2. So because of that, it's a concave down parabola, and what we're just saying is, at the point where x is equal to 2050, this is where we have a maximum y value. Okay, that's the maximum income there. Okay, so we've just found the value of x. Now, read into the question. They specifically say, calculate the maximum daily income per room. Okay, so it seemed like they were referring to this amount. But here's the difference between I and x. So I tells us the total daily income, okay? So the total daily income, not per room, as in we have, just like how we calculated it, we have the rent per room, and then multiply by the total rooms. So this is the amount that the hotel is going to make on that day because of all the rooms that were rented out. Now, initially they told us that X rand, okay, is the rent per room per day. Okay, so that's what we're looking for, that per day. So from the question, they specifically said, calculate the maximum daily income per room. And so since whatever rent is charged is going to be whatever will be received as income, then it means that that maximum daily income per room is referring to the rent per day, okay, like that X rand. So the values of X is the rent per day. And that's what we just found. We found the value of X. So that means that this is 2,050 Rand. And that is our answer. And that is it for question 10. Question 11.1 says, events A and B are mutually exclusive. Okay, so if they're mutually exclusive, then it means that these circles will not intersect. And so what that means is because we don't have an intersection, that probability of A and B is equal to 0. Okay, and then they tell us that the probability of B is twice the probability of A, and the probability of A or B is 0.57. Okay, so let's go ahead and find the probability of B using this information that we have. So because they've given us the probability of A or B, we can use this rule. So the probability of A or B, and to find the probability of A or B, we say the probability of A plus the probability of B minus the intersection of A and B, which we know is 0 since they are mutually exclusive. So the probability of A or B, that is 0.57, is equal to the probability of A plus the probability of B, which they told us was 2 times the probability of A. So you see that this equation will solve for the probability of A, but then we can use that to solve for the probability of B. Okay, so this is equal to, if you say probability of A plus twice the probability of A, it's just like saying X plus 2X. So that is 3 probability of A. And that's 0.57. Then we can just divide both hand sides of this equation by 3. Therefore, the probability of A is equal to 0.19. Okay, so 0.19. And now we can find the probability of B. So you see how they told us the probability of B is 2 times the probability of A. And that's how we'll find that. So probability of B equals 2 times probability of A. So it's just 2 times 0.19. Okay, so 2 times 0.19, and that gives us, okay, that is like 2 times 20, which is 40, and then minus 2. So, okay, so this will finally be equal to 0.38, and that is our answer. Moving on to the next question. Question 11.2 says, a box of 40 calculators is sent to a store by a supplier. The owner of the store is not aware that 5 of the calculators are defective. 2 calculators are selected at random from the box, the first one not being replaced before the second one is selected. Okay, so we're just not replacing. And then 11.2.1 says, what is the probability that the first calculator chosen is not defective? Okay, it's the first calculator chosen. If we know that there is a box with 40 calculators, 5 are defective, then it means that 35 are not defective. And so the probability that when these calculators are in the box that you're going to pick one that is not defective would just be 35 out of the total 40 calculators we have. Okay, so this is just 35 over 40, which these are both divisible by 5. 35 divided by 5 is 7, and 40 divided by 5 is 8. And that is our answer. Moving on to the next question. Question 11.2.2 says, what is the probability that if 2 calculators are selected, one calculator is defective and the other is not? Okay, so we can actually just draw this tree diagram because we are selecting calculators here. So in this tree diagram, we have calculators that are defective and the ones that are not defective. We know that there are only 5 that are defective, so out of the 40, and then 35 out of 40 is not. So in the first pick, when you're picking out a calculator, the probability that it will be defective is just 5 over 40, and the not is 35 over 40. Then remember that these calculators will not be replaced. Okay, they won't be put back as they said in the first part of this question. So it means that the probability that you're going to pick out a defective calculator, if the first calculator that was picked was defective, would be, it means that there will be one less defective one, okay, over a total of how many calculators? Well, one calculator was picked out and it wasn't put back, so over 39. And then the probability that we will pick out a calculator that is not defective. Remember, we're saying if a defective was picked out first. So the ones that were not defective has not been picked out. So there's still 35 of them out of a total of 39 calculators because a defective was picked out. Okay, same thing over here. The second pick would work like this. It could work like this. If it was a non-defective calculator that was picked, then what is the probability that a defective calculator would be picked in the second pick? So it's a non-defective that was picked. Defective was not picked in this situation, okay? So it means that there would still be 5 defective calculators, but we know that a non-defective has been picked, meaning there are 39 calculators left in the box. And then what is the probability that we would pick a non-defective in the second pick, given that a non-defective calculator was picked? Okay, if a non-defective calculator was picked, it means now you have 34 non-defectives over 39 calculators because one has been picked. So this is what it's going to look like. And the question specifically just wants us to find the probability that the calculators picked, okay, if we're picking 2 calculators, one calculator is defective and the other is not. So here's how this is going to work. Okay, defective and not. We're just going to have to look at these outcomes. So all the outcomes we could get in these 2 picks. So here we could get defective and defective. Okay, and then you could also get a situation where the first pick you got a defective calculator and then in the second you got a non-defective. So defective and non-defective. You see that this is one of the cases that they're referring to. Okay, because one is defective, the other is not. And here's another outcome that we can have. We could pick, in the first pick, we could pick a non-defective calculator. And then in the second pick, we pick a defective. And the last outcome we'll have is we pick a non-defective calculator and a non-defective in the second pick. Okay, so these are all the outcomes that we can get. And we need to just look for the one that has defective and non. You see that there are 2 outcomes that we have like that, defective and non-defective and and defective. So we're just going to have to take that. So here's how we'll find that. We're taking the probability that we're going to pick out a defective in the first, okay, and a non-defective in the second. So it's just going to be, so we're taking that and we're taking this. So we're just saying we could take this or this, meaning we're going to add these values. Because these 2 cases work, okay? So then the probability that it will be a non-defective at first and the second one will be defective. And that's all we're going to add together. So let's look at the outcomes. It's defective and non-defective. So that is the 5 over 40 multiplied by 35 over 39. And then we add that to non-defective pick first, okay? We picked out a non-defective calculator. So that is 35 over 40 multiplied by and defective in the second pick. So that is 5 over 39. And all we'll have to do is calculate this. And that is our answer. And our answer is 35 over 156. And I'll just leave it as a fraction. Okay, so that is it for question 11.2.2. Question 11.2.3 says, what is the probability that if 2 calculators are selected, both are defective? So we're just looking for defective and defective. So do we see that in our outcomes? Yes, we do. It's this first one. Okay, probability of selecting a defective in the first and a defective in the second pick. So that's going to be 5 over 40 multiplied by 4 over 39 because they're happening together, so we multiply. Okay, so 5 over 40 multiplied by 4 over 39. And let's just find this answer. Okay, we can just calculate this. So 4 divided by 4 is 1. 40 divided by 4 is 10. 5 over 10. Okay, so 5 divided by 5 is 1. 10 divided by 5 is 2. So that's 1 over 2 times 1 over 39, which is 1 over 39 times 2. That's 80 minus 2, which is 78. Okay, and that's our answer. 1 over 78. But you're probably not going to want to cancel these things. Just do it with a pencil and then leave that so they can see your calculation. Okay, moving on to the next question. Question 11.3 says 4 different economics books and 3 different life science books are required to be placed on a shelf. So there are 4 economics books and 3 life science books. And 11.3.1 says, if you decide to place any book in any position, in how many different ways can you arrange the books on the shelf? Okay, so just remember these are different books. They're not exactly the same. So we're just looking at it like this. There are 1, 2, 3, 4, 5, 6, 7 positions. Okay, now before the first book is placed down, right? When we're deciding on where to place this, how many different places could it sit in? It could sit in the first place, the second, third, fourth, fifth, sixth, seventh. Okay, so this first book has 7 different options to be placed in. Then once the first book is placed down, the second book would have 1, 2, 3, and there are 6 spots remaining, meaning it can be placed in any of these 6 spots. That's 6 choices. Then once that is placed down, the next book would have 5 different choices. Then the next 4, the next 3, 2, and 1. Okay, so these are the options and we're going to multiply them. And that gives us 7 factorial. Okay, so you can write it like that, or you could just say 7 factorial. And then on your calculator, say 7 factorial. Okay, it's that button. And this is 5,040 different ways. Okay, they just said in how many ways. So you can just tell them it's 5,040 ways. Moving on to the next question. Question 11.3.2 says, if 2 particular books must be placed next to each other, in how many different ways can you arrange the books on the shelf? Okay, so 2 particular books. They don't say which books. So let's just see it like if we had to just group 2 random books together and they have to be placed next to each other, here's how we can look at this. So we're just going to group 2 books together. Okay. Now, in how many ways can they be placed on the shelf if these 2 must be together? Okay, so looking at them, like these 2 books on their own, right? They can be placed as, remember that they are 2 different books. So they don't have to be placed in this order where this economics book is first. It could be this economics book first. So it could be placed like this, where this one is in the first position and the second. Or it could be in a way where this one is in the first position and that one is in the second. Okay, so on its own, it has 2 different ways or options to be placed at. If you like, you can say 2 factorial, which is what we usually do. And then now remember that the books can be placed anywhere. They don't have to be placed here. Okay, so now that we have that, now it's kind of like looking at them as if they are groups of their own. This is one group. This is another group of its own, another group, and those are groups of their own. So now we're looking at the placement within these groups. So these 2, they don't have to be in front necessarily. They could be in this position. Okay, they could be here, they could be here, and here, and here. So looking at the group positions, you see that there are 1, 2, 3, 4, 5, 6 positions there. So this group has 6 different options it could be placed in. So we'll look at that as 6 multiplied by, and then once placed down, the next book or the next group, okay, of its own, it's going to have 5 different options to be placed at. It can be placed here, 2, 3, 4, 5, okay? And then once it's placed down, the next book would have 4 different places to be placed in because they're not restricted to just these positions. They can move around. So that would have 4 different positions, and then the next one will have 3, and then 2, and then 1. So altogether, this gives us 6 factorial. Okay, and that's how we would find this. 2 factorial times 6 factorial. And that gives us 1,440 ways. Okay, now just check if they asked for the probability. No, they didn't. They just said in how many different ways. So that is our answer. And moving on to the next question. Then question 11.3.3 says, if all the economics textbooks must be placed next to one another, and all the life sciences textbook must be placed next to one another, in how many different ways can you arrange the books on the shelf? Okay, so in this case, we are grouping all of these books. Okay, the economics are together, life science are together. So let's group them. It means that this is a group and this is a group. Okay, so let's look at the ways they can be placed on the shelf. So with the economics textbooks, as a group, as this little group of their own here, remember that these 4 books are different books, okay? They're not the same. So it means that as they are like this, the total ways they can be placed in would be 4 factorial. And the reason why is because the first book, again, has how many different places in this little group to be placed in. It could be put here first, okay? It could be put in the second position, the third, or the fourth. Okay, and then once placed down, then the second book would have how many different options? That's 1, 2, 3. And then once placed down, the third book has 1, 2, and once placed down, the last book just has 1. So that's why it's 4 factorial. 4 times 3 times 2 times 1. And likewise with this, that would also work like that. Okay, first book has 3 different positions, and then 2 different, and then 1. So that's 3 factorial. Okay, so now that it looks like this, we can look at them as a group. This first group, when we are placing this down on the shelf, right, we have 2 positions, 2 group positions. They could either be here in front of the life science textbooks, or they could be in place of the life science textbooks. So that means the life science textbooks will come first. So that means that group has 2 choices, okay? Then once this group is placed down, then this next group, we're looking at these groups as if they were individual books. This next one has only 1 choice to be placed in. So that will be times 1. So you see how that's 2 factorial, 2 times 1. So the answer will be 4 factorial multiplied by 3 factorial multiplied by 2 factorial. And let's get our answer. And this is 288 ways. Okay, so we can just tell them that it's 288, and this is just in how many different ways. It's not the probability they're asking for. So that is our answer. And that is it for question 11. Okay, so that is it for this paper. I hope you guys enjoyed it, and I will see you guys in the future videos.